Want to secure a grade 7 and above for GCSE Higher Paper 2 and 3? Come on then, watch this video now. Hello guys, welcome to our GCSE and Mock Paper 2 and 3 walkthrough. I know guys it's a bit late, but guys I've been so ill over the past few weeks. I couldn't record this video without sneezing and coughing. So guys, I've prepared this walkthrough a little bit different so that you are prepared for the 2 final papers. So I've done both of them in one. So don't be alarmed by the length of this video. You still have a few days to cover it all. Now, for this revision, you're going to need a pencil, a protractor, compass, ruler, and of course your calculator, which by the way, make sure it's on degrees. Thanks to every one of you who have liked, hype, and by the way guys, I want to make sure that you help me to get this video out in this late stage of the game. So what I want you to do, each of you have 3 hypes per week. Please hype the video 3 times so people can get this out, because you would agree it's very late. But guys, as I said before, I've tried my best to ensure that you get your revision. Lots of you have commented in the comment section saying, Miss, what about paper 2 and 3? And if you know me well, you know that I would not disappoint you. So the fact that this is late, you know something was off with me. And by the way guys, if you watch this on the 28th, which is Thursday, it is tomorrow of when I'm recording this, then that's my birthday. So this is my gift to you. I don't have a cake to share, but I'm giving you the knowledge that I've got. So in the comment section, just drop me happy birthday, miss. And clearly you can still hear that I'm not all the way well either. So now guys, I want to make special mention at chocolate chips banana bread for engaging in the comment section, at Marian47215, at Mia Kane VR2LX, at Shav1858, and Eric. Eric, I hope I can say your handle well. So it's Eric Ramakishan. I hope I got it right. But guys, you have been so good in the comment section, talking back to me, letting me know how your paper was. And of course, telling me your expectation that you need this video for your paper 2 and 3 and how useful the paper was. Before we get started guys, I forget to mention to you that lots of the topics that we covered in the paper 1 part 1 and 2, they're coming back. We haven't seen them on paper 1, but we've done so much. A simultaneous equation, the one where we are doing simultaneous with the quadratic one and so on, factorize, guys, so much there. You need to make sure you go through this video and go back through those as well. And come back to tell me at the end of those papers that you have slayed them. And also in August when you get your result, make sure that you tell me that you passed, because I know you will. And so guys, with all of that being said, I'm so happy you're a part of my community. And so come, let's prepare and get through this walkthrough together. We begin with number properties. We're asked to show that 2125 can be written as a cube number multiplied by a prime number between 10 and 20 for 2 marks. So key point here is that we need to have a cube number. So I'm just going to write cube number here. And we need to have prime number. And the criteria is that the prime numbers have to be between 10 and 20. So a good practice is to make a list of these numbers first of all. So our first cube number is 1, since 1 times 1 times 1 is 1. Then 2 times 2 times 2 is 8. Next cube number is 27, followed by 4 times 4 times 4, so that's 64. And then 5 times 5 times 5 is 125. So let's write our prime numbers now between 10 and 20. So we have 11, 13, 17, and then we've got 19. Beautiful. So another thing that we could do, since we know it's going to be one of this cube number multiplied by a prime number. I can also go now to do my prime factorization. So I can see that my number here ends with a 5, so I'm going to divide by 5. Remember, guys, this is your calculator paper. So straight ahead, we're going to do 2125 divided by 5, and that gets us to 425. So here we got our prime number. So next we are dividing by 5 again, putting that in your calculator. 245 divided by 5, which gets us 85. Again, dividing by 5, I will now have 85 divided by 5, which is 17. So we have 5 cubed, so clearly we got our cube number, times by 17, which is also our prime number. But careful now, do not leave your number in cube form. It says a cube number, so we're going to write it as 125 times by 17. Calculator paper, we check that back. So clearly, we used 125 and 17 for 2 marks. We're thinking clearly through those 2 markers. So the next question told us that A is a common factor of 72 and 120. B is a common multiple of 6 and 9. So common factor, a lot of time we mix up factors and multiples, which we cannot afford to do now. So B is a common multiple of 6 and 9. Work out the highest possible value of A divided by B. So I've got to think, this is 4 marks, I've got to think clearly. If I'm going to get the highest possible value of A divided by B, it means that I need the largest possible value of the common factor. So we need the largest common factor, and we need the smallest multiple, which is going to be the lowest common multiple of 6 and 9. So we're going to find the highest common factor using our factor tree. So let's go for 72. So we can split 72 into 9 and 8. So 8 9s, 72. And then I'm going to break this again in 2 and 4. 2 is a prime number, and 4, 2 and 2. So we then need to do for 9, which is 3 and 3. So 72 is equal to 2 to the power of 3 and 3 to the power of 2. Let's go for 120 now. So 120, we can split that up into 10 and 12. We can then do 10 in 2 and 5. And then 12, we can do 3 and 4, and then break our 4 in 2 and 2 again. So we can write 120 is equal to 2 to the power of 1, 2, 3. And that's been multiplied by 3 and also by 5. Just check and make sure we've got it all together. So now we need to take the highest common factor. So the highest common factor among the 2's, 2 cubed is common to both of them. However, there is just 1 3 that's common to both. So we take that, no 5 common, so we just need to multiply 2 cubed, which is 8, times by 3. Again, guys, just put this into your calculator. That gets us 24. So that means the value of A that we're using is going to be 24. Now we need to get the lowest common multiple of 6 and 9. So again, by listing 6, 12, 18, let's go for 9, 9, 18. So first common one that shows up is 18. That means for B, we've got to use 18 since it's the smallest or the lowest common multiple. So let's go now. So A divided by B then, our A value is 24 and our B value is 18. We could get that as a decimal, but I think it's better to leave as a fraction. So if it didn't ask us in its simplest form, we could leave it as 24/18. Again, you can use your calculator to simplify that straight away. So we get 4/3 for our final simplification. And there we have it. So just thinking about and reasoning, guys, through your questions will get you to the correct answer. Beautiful. We're still on number properties. We're told here P is a positive number. N is a negative number. For each statement, tick the correct box. So we're going to check on these. A good practice here for 4 marks is to select a value for P and a value for N and work along with those. So I'm going to select that my P is equal to, so let P be equal to 4, for example. And let N be equal to negative number. So I'm going to choose -1. Great. So let's check the criteria now. If I do P plus N, I'm actually doing 4 plus -1. And that gets me +3. Again, no excuse. We got a calculator paper. So yes, it's positive. But I also have to think, what if my positive number was 1 and my negative was the -4? How does that impact the answer? So this then will give me minus. So we can see it is not always positive, but sometimes. So for that one, we will say it is sometimes true. Beautiful. Next we go using the same numbers, testing along the next criteria. So P minus N. So when P is positive, let's do 4 minus. I'm subtracting a negative. And that's going to make me have a positive here, so I get 5. Let's see if that changes when I make my P to be +1, take away, and I make my -4. Still gives me +5, and that's because 2 negatives together is also going to make a positive. So clearly we can see that this one is always true. Beautiful. So we go for P squared plus N squared. So keeping P as 4, we're doing 4 squared plus -1 squared. We know that when we square a negative, the answer is still going to be positive. So essentially, this is 8 plus 1, which is going to be 9. And what if I did it the other way around as well? If I did it the other way around, I would now have 1 squared. We can see -1 squared will still give us positive. So this one is also always true. We will get a positive as well. Then we're going to look at the last criteria where we're doing P cubed divided by N cubed. So if we cube P at 4, that will give us +64. We are dividing that by N, so -1 cubed. When we cube a negative, we will still get a negative. So dividing a negative into a positive will still give a negative. So we can see didn't get a positive at all. Even if we swap them around and make the 1 comes first, we are still essentially going to be dividing by a negative. And that will still end in a negative. Therefore, this is never going to be true at all. So don't just think it in your head, guys. You got to ink it, talk yourself through it. 4 marks, show evidence of how you got your answer as well. Lovely. So now we go on to ratio in N to 1. We're told here that at a school, there are 912 students. Underline key facts. The ratio of students to teachers is 15.2 to 1. The number of students stays the same. Okay, that's important. The number of teachers, however, increases by 2. Work out the new ratio of students to teachers. The order matters. Give your answer in the form N to 1 for 3 marks. Beautiful. So with the information we have, first of all, I need to work out how many teachers we have altogether already present here. So let's write the ratio is 15.2 to 1. And we knew that it was students first and then teacher after, which means that 912 represents 15.2 ratio parts. Therefore, I can do 912 divided by the ratio parts, which is 15.2. Put that in my calculator and see what is the scale factor. And then it will be the same scale factor that gets me the number of teachers as well. So 912 divided by 15.2, that is equal to 60. So my scale factor here is 60. So therefore, I had 60 teachers to begin with. Okay, so I know that I've got 60 teachers. I'm told that the students stay the same, but the teachers increase by 2. So now I know I have 62. So 60 plus 2 will be 62 teachers altogether. Now I need the new ratio. So I still got my 912, but now I've got 62 teachers. I'm asked to give my answer in the form n to 1. So my 1 has to be on my right. To do that, I need to divide both sides by 62. Calculator paper. I'm maximizing my opportunities here. So 912 divided by 62 gets me 14.7 to 1 decimal place, and 62 divided by itself is 1. So therefore, the new ratio is 14.7 to 1. Make sure you write that clearly on your answer line, guys. Cannot stress it enough. Your answer line is the most important line on that paper. Beautiful. Okay, so we now go to another ratio question. We're told here that Saj makes rose pink paint and cherry pink paint. Underline what is made. We can see it also here in the box as well, rose pink and cherry pink. He mixes red paint with white paint. So I'm putting R and W to give myself the focus. We've got it here as well. He makes 60 liters of rose pink paint. Key information here. All of this rose pink here in the first box is equal to 60 liters. Beautiful. To this rose pink paint that he's got, he's going to add 80 liters of red and 28 liters of white paint. So question, has he now made cherry pink paint? You must show you're working. Now, if he's going to make cherry pink paint, we expect that the ratio here for cherry pink will be 4 to 3. So what I'm after here, I'm trying to see, after I finish adding the red paint and the white paint that we were told about, if we get the ratio 4 to 3, then yes, he would have made cherry pink paint. If not, he has not. So that's what we're trying to answer. So we're going to use what we got here for red and white, and that's 1 to 2. We're going to find out how much portion of red, how much portion of white, and then do the addition to that. So adding our ratio parts, I get 3 altogether. I know that we've got 60, so I need to find out how much red, how much white. So I need to do 60 divided by 3. Calculator, guys, don't take it for granted that you know everything. Don't use your head, use the calculator. So 60 divided by 3, and that is equal to 20. So now we know that red is 20 parts, 20 liters, and then white will be equal to 2 times by that, 20. So 2 times 20 is 40. Okay, for white. Okay, so we got 20 to 40. Key information here now is that to this we're going to be adding 80 liters of red. So red will now be equal to 20 plus this 20 we got here plus the 80. So red is now 100 liters. And to the white, which was 40, we are now adding what they told us, which is 28 here. Again, use your calculator, easy things to slip. So 40 plus 28, leading by example here, is 68. Absolutely brilliant. What we need to do now is to check if this ratio is in 4 to 3. If it is, we've made cherry paint. So we've got 100, and that is 268. So simplifying that, I get 25 to 17. Cannot be simplified any further. However, guys, if I was supposed to have, so if you look here, 100 to 68, let's see what we should have if we would have gotten ratio 4 to 3. So we can see if this is a ratio of 4, this would have gone up by multiplying by 25, and the 3 times by 25. This would have had to be 75 also. So we say no, he did not make cherry paint. Make sure you write that all out. No, he did not. And then you can also qualify this by say ratio should be 100 to 75 if he did. Okay, you're just showing your examiner my thought process here. I know what it is that it should look like if it is that the answer was yes. Absolutely fantastic. So now we carry on with another ratio question. We're told here that D is equal to 2F. We are given a fraction that e minus f divided by d take away e is equal to a quarter. We're asked to work out the ratio of e to f. Now, guys, we know whenever we're given information in a question, we're not given that amiss at all. We are given it because at some point in the question, we're going to need to apply that information that we were given. So what we're going to do, first of all, we're going to be simplifying our fractional ratios. So that's equal to 1/4. So I'm going to cross multiply them. So I need to do 4 bracket. Don't forget, you've got to expand the bracket using 4. That's the distributive law. And then 1 times d minus e is still d minus e. So now I need to expand my bracket. So 4 times e is 4e. And 4 times minus f is minus 4f. Don't forget that. That's equal to d minus e. So I have to see the opportunity here. The reason I was given d is equal to 2f is that if I rearrange this, I will be able to substitute the value of d into the question. Therefore, what I need to do now is to take the minus e to the other side. So 4e, this minus e is now a positive e. And then I also have 4 minus 4f equal to d. Can you see where we're going now? I hope you do. Collecting my like terms here, I get 5e minus 4f is equal to d. But for this d, I now need to replace it with 2f. So now I will have my ratio in e to f. That's what I'm after. I cannot have d at all since I was asked to make the ratio of e to f. So let's go ahead now and make sure that we can simplify this. So we're going to put our f terms together. So you can see here, if I put my minus 4f to the other side, it will now be positive. So 5e is equal to positive 4f and positive 2f. So 5e is equal to 6f. Now I can see, I can set up my ratios now between them. It takes 5 of e to make 6 of f. What I can do to see this even clearer is to rearrange to make e the subject. Then I'll know which one of the ratios I should, because most of the time students get here, then you mix up which one of them is the bigger ratio. So let us rearrange to make e the subject to make it even more clearer. So if I divide both sides by 5, I can see that e is equal to 6/5 of f. So 6/5 of f. Now I can see which one is the bigger one. So let's write our ratio e to f. So if e is equal to 6/5 of f, then e is the bigger one. So we got 6 to 5. And that's our final answer. So you can see here we had to do a bit of expansion of bracket. We got to collect our like terms, and also we have to rearrange to make particular variables the subject of the formula. And this is the difference between a top grade and a grade 5 or 4, guys. You have to be able to interleave all of the topics across your curriculum when it matters. Beautiful. Okay, so now we're going to move to another question on ratios, different style involving area. So we're told here that P is a rectangle with length 50 centimeters. We can see that on the diagram here. So this is just basically describing the diagram. And the width is x centimeters. Q is a rectangle with y centimeters. The width of it is y centimeters. Okay, not drawn accurately at all, so we cannot measure. We're told here that the length of Q is 20% more than the length of P. Beautiful information there. The next bit, we're told that the area of Q is 10% less than the area of P. We're asked to work out the ratio x to y and give your answer in the simplest form. Underline key facts for 4 marks. So we got to make sure that we give it to the degree of accuracy we were asked to do. So we're going to take it step by step now, working on each bit of information. So we're told that the length of Q is 20% more than the length of P. The length of P is 50. So let's go. Length of Q then, as a multiplier, 20% more, the multiplier will then be 1.2. So we need to do the length of P, which is 50, multiplied by 1.2. Let's put that in our calculator straight away. So 1.2 times by 50, that is equal to 60. A good practice here, guys, write on your diagram. Put that in. It's 60, so we're going to put it on the diagram. Beautiful. Tick that off now. Clear, logical thoughts. So the area of Q is 10% less than the area of P. 10% less than the area of P. So we're thinking of 100%, take away 10%. That means it's going to be 0.9 for our multiplier. But first of all, I need to find the area of P. So let's write logically. Area of P is equal to the length times the width, which is 50, multiplied by x, which is 50x. So we can see we have to represent the area of P algebraically as well. So that means if it's 10% less, it's going to be 50x multiplied by multiplier, decrease 0.9. Put that in my calculator. So I've got 0.9 times by 50, which is 45x for the area. We can even put them on the diagram, 50x here, and then we've got 45x. So what we need to do now is to match the areas up. So we've got here 50x for this area. We're told to write the area of x to y. What we have to recognize here is that we know that this is 45x. However, the area of Q as is, we were given the length of it to be y. So let's go. So we know that 60 times by y is 60y. And we know what that is equal to. It's actually 45x. So let's go. 45x is equal to 60y. Beautiful. Now we've got the ratios in terms of x and y. We can now represent them, but we must do that in the simplest form. So what we need to do now, let's see which one is bigger. It takes 45 of x to make 60 of y, which means that x is bigger. So I can then write them as a ratio, x to y. X is bigger, so that's 60 to 45, and then I've got to simplify. So I can divide them by 15. So 15, 60 divided by 15, that is 4. And 45 divided by 15 as well, that's 3. So in its simplest form, then we've got 4 to 3. Brilliant. Make sure you use up your calculator as much as possible, guys. I cannot stress that enough at all. Okay, so we're going to be moving on to another ratio question, but guys, I've got to make sure that you have made a comment. Let me know. You can hear, guys, I'm not really well. I'm really trying to get this video to you. Make sure that you let me know how useful this is, and also just drop a like as well. Get the algorithm to get it out, and other people are really waiting for this video, guys. Some of them haven't pressed all on the notification bell, but I'm sure if you share, hype the video, the algorithm will get it to them, even though they didn't press all. So we're told that rectangle ABCD is split into 4 smaller rectangles. 2 of the smaller rectangles are shaded, as we can clearly see. The diagram is not drawn accurately at all, guys. We're given that 4 to x is equal to 1 to 2 in terms of our ratios. So for rectangle ABCD, we're asked to work out the ratio. So make sure that we underline key thing. We're working out the ratio of the shaded area to the unshaded area. Give your answer in its simplest form. So we check on here, we can see that the question itself gave us the area of the unshaded bits, which means all we need to do is to find the area of the shaded bits. So we've got to be able to see that we have to use the key bit of information they've given us here to work out the value of x. So we've got 4 to x, and that's equal to 1 to 2. We can set that up as 4 to x and put underneath 1 to 2. So clearly, if I multiply them across, I can see 4 times 1, I can see that 1 times x is x, and then 4 times by 2 is 8. Therefore, the first value here is that x is equal to 8. We're going to put that in on the diagram. Guys, a good practice always write on your diagram. Little bits of information you may miss if you didn't put it in the working space, but we see it on the diagram, you will get the full mark for that. So let's say that you didn't put x equal 8 in your working space here, but we found it on the diagram, full mark for that as well. So now, guys, we can easily work out what is the area of this shaded bit, because if I know that this is 8 here, I can find out the length along here. What number times by 4 gives this 12? Has to be 3. So therefore, I've got the length and I also have the width. So therefore, 8 times by 3 gets me 24 centimeters squared. So let's put that here, 24 centimeters squared. Again, I can use this knowledge. This is 8 as well. Since it's a rectangle, this length along is also 8. 56 divided by 8 gets us to the length that's missing here. So 56, again, calculator paper, 56 divided by 8 is equal to 7. So this bit here is 7. And if I know this along here was 4, then 7 times by 4 gets me 28 centimeters squared. So let's put that on the diagram. Now I'm ready to get my total for the unshaded and the total for the shaded area. So let's go. We need it in the form shaded to unshaded. Very important. The order does matter. So let's get for the unshaded bit, I will have, so unshaded would be equal to, I've got 12 plus the 56. I'm using my calculator, guys. So 12 plus 56, that is equal to 68. And then for the shaded bit, I'm just going to put SH for shaded. I've got 24 plus the 28 using your calculator. So 24 plus 28, and that gets me 52. So now I'm ready to put them in order. I've got 52, and that is going to 68. Again, check my degree of accuracy or how my answer should be represented. We're told give it in its simplest form, and a calculator paper easy to simplify. You can half first by dividing by 2. 56 divided by 2, I get 26. And half of 68 is 34. I can see I can also half again. Half of 26 is 13, and half of 34 is 17. So my final answer is 13 to 17. Absolutely fantastic. You think, so guys, before I move on, a lot of people believe that because it's a calculator paper, you can just do all the calculations and then put down the answer. Absolutely not okay. We need to make sure that we are writing out the steps. The calculator is just an aid, does not do the work for you. Okay, so make sure you show everything as I've done it here as well. Moving on to proportional reasoning. We're told that 15 machines, notice how I underline everything, work at the same rate. This here is important. Together, the 15 machines can complete an order in 8 hours together. 3 of the machines break down after 6 hours. So 3 break down after 6 hours. The other machines carry on the work until the order is complete. In total, how many hours does each of the other machines work? So we want to find out in total, how much does the working machines that carried it all the way through, how long did they work for? Okay, step 1. Step 1, I need to find out what is the total hours that all 15 machines I've taken, that's 8. So I need to find out how much does one machine take. So one machine would be equal to 15 multiplied by the 8 hours. So it will take the total time for all of them. So we go for 15 multiplied by 8, and that gets us to 120. So that's for one machine. You scored your first mark already. We're told that, so let's check that off. We've used that information. 3 of the machine break down after working for 6 hours. Okay, so we need to find out how much time was gone already before these 3 machines break down, so for 6 hours. So I need to do my 15 machine multiplied by 6 to see how many hours were gone already. So 15 times by 6, so that was 90 out of the 120. Therefore, we need now to find out how much hours is left to complete the job. So I need to do 120 take away 90. Again, guys, I'm putting it in my calculator. Easy question, but put it there. So there is 30 hours left to go. But how many machines are functional to carry through this 30 hours is important. So 3 machines break down. So 15 take away 3, leave me with 12 machines to go. So 12 machines have to complete the other 30 hours that's left. So let's see how much does one of those machines take. So we need to do 30 divided by 12 to see how much one machine will take. So 30 divided by 12 is 2.5 hours. Remember now, question asks us in total, how much did one machine take? So in the beginning, they all worked up to 6 hours. Okay, so we need to do total would be our first 6 hours that they took, plus for the last bit of the job, they took 2.5 hours. So in total, 6 plus 2.5 gets us to 8.5 hours. And there we have it. Just that clear, logical thought, breaking down the question one step at a time. Underlining key fact would be one of your winners if you apply that concept. That will bring in focus what it is that you are meant to do for each stage of your journey. Beautiful. So we carry on with proportional reasoning. We're told here that a stone falls vertically from 300 meters above ground. The stone falls d meters in t seconds. From we hear that language, guys, we know we're either going to do direct or inverse proportion in this question. We're told that d, there we go, is directly proportional to the square of t. So without any further ado, I'm writing what I heard straight away. D is directly proportional to the square of t, so to t squared. Let's get that down on paper. Now, the stone falls 20 meters in the first 2 seconds. Work out the total time taken for the stone to reach the ground. Beautiful. So first of all, I'm giving some key information here that I can use. So if d is directly proportional to t squared, it deduces that d will always be equal to, remember, our constant k multiplied by t squared. Now, whether or not the question tells us to, we always need to find an equation that links our two variables together. We are given here our starting point. So the stone falls 20 meters, so that's our distance. So we're going to substitute d for 20 equal to k, which is our constant, times by t is our time here. So that's 2, and that is being squared. So 2 squared is 4, so 20 is equal to k times by 4, which is 4k. Then we need to divide by 4. 20 divided by 4 is 5. So k then is equal to 5. So let's put that in a nice equation now. K then, so d will always be equal to, replacing this k for 5, will always be equal to 5t squared. Beautiful. So we got our first part of our question done. Now, the question then asks us the total time it takes for the stone to reach the ground. So we knew that the distance is going to cover is 300. So we're going to substitute that in and work backwards to find the time. So D is equal to 5t squared. So the distance we're trying to cover is 300 and 5t squared. Again, rearranging formula. So we've got to divide both sides by 5. I'm not taking any chances and I'm teaching you what I want you to do. So 300 divided by 5, that is equal to 60. And that's equal to t squared. But I'm not after t squared, I'm after t. So I need to square root both sides. So square root of 60 is equal to 7.575, and that is seconds, and that will be equal to t. So therefore, t is equal to 7.75 seconds that it will take. Now, guys, most of the times you are given the unit on the answer line. If not, make sure that you put your seconds there as well. Absolutely fantastic. The easiest question you could be given on proportion. Okay, so now we go for another similar question, this time for 5 marks. Clearly, the marks indicate that there is more work to be done for this one. So we're told that P, Q, and R have positive values. Very important here, positive values. P is directly proportional to the square of Q. So T is directly proportional to the square of Q. We are told that P is equal to 1.25 and Q is equal to 0.5. Straight away, I know those are my starting values that will help me to get my constant K. Now, another scenario is that Q is inversely proportional to R. When Q is 0.5, R is equal to 6. We're asked to work out the value of R when P is equal to 0.8. Indicative here, we will have to find a relationship that links R and P. So we go back, having read this, we're going to now go back to set up our equations. First bit here, P is directly proportional to, so P directly proportional to the square of Q, so Q square. What does that tell us? P is always going to be equal to a constant, which is K, multiplied by Q squared. Guys, make sure you read these questions properly and not losing marks for squaring or square rooting and not remembering that you need to follow the rules. Some people rush ahead and instead of squaring, they do square root and so on. That's not us though. Thank you. So now I need to find out K. Remember, we are always after our constant first and our equation that links them. So using the value for P to be 1.25 equal to K multiplied by Q, which is 0.5. Common mistake is to forget to square. Do not forget, we've got a P squared. So I'm going to be doing 1.25 equal to 0.5 squared. Put that in my calculator. I get 0.25 in terms of K. To find K now, I need to divide by 0.25 on both sides. So 1.25 divided by 0.25, and that gets me 5. So K then, this cancels out, so K is equal to 5. Remember, let's write the equation that links them. So P then will be equal to, instead of K, I know K is 5, so that's going to be 5Q squared. Absolutely brilliant. So now I need to take on the next part of this journey. You will see why we need to work all the way through for 5 marks, guys. So Q is inversely proportional to R. So we know that Q is going to be equal to the constant this time divided by R. Inverse proportion. Okay, so we're going to use our values we were given, and then we're going to work out what is the constant that links Q and R. So using Q for 0.5, I have 0.5 is equal to my constant divided by r, which is given to be 6 in this question. So I need to do 0.5 times 6. So k is equal to 0.5 times by 6. Use your calculator, guys. Our constant k is equal to 3. So the equation that links them then, q will always be equal to, replacing k with the value here for 3, is 3 divided by whatever r is. So 2 equation we have found a link for. Now, the key principle here now is that we were asked specifically to find the value of r when p is equal to 0.8. So we can see that r is within the equation for q. So if I find the value for q, I can then substitute it in the equation for q, and then I'll be able to find r. So using p equal 5q squared, we're going to substitute this value of p in for 0.8. So 0.8 is equal to 5q squared. So I now need to divide both sides by 5, and then I will square root to find what q is. So let's go 0.8 divided by 5. That gets us to 0.16, and that's equal to q squared. Guys, don't forget to do your square root. So I'm square rooting both sides now. I've got my answer, so square root of answer, q is equal to 0.4. So therefore, I can now substitute this value of q in the equation for q, and then I find r. See, 5 marks, guys. So q is equal to, so I'm just rewriting this to bring back my equation in focus. Q is 0.4. 0.4 is equal to 3 divided by r. So we need to do 0.4 times r is 0.4r, and that's equal to 3. So therefore, I'm going to divide by 0.4 on both sides. So r then is equal to 3 divided by 0.4, and that gets me 7.5. Absolutely fantastic there. So you can see it's just linking everything that you know. I know direct, I know inverse, I know how to substitute, and therefore all I need to do now to bring this home for 5 marks, use my calculator to my best advantage. Absolutely brilliant. So now we go to percentages, starting with easy percentages, then reverse percentages, all the way up to compound. So we're asked here to work out 420 as a percent of 70. Easy to slip, guys. Remember, it's 420 out of 70. And we need that as a percentage. Fraction button. Press your fraction button. Put 420 at the top, 70 at the denominator. Multiply by 100 equal. And the answer is 600%. Beautiful. I know I'm correct because clearly 420 is far greater than 70. Beautiful. Next question we go for. Let me just do this one first. So I'm asked to do 70%. We're told 70% of a number is 350. We want to work out 120% of the number. Clearly, guys, we need to find out what the number is first, okay? So I know 70% is equal to 350. I can then do reverse percentages to find out the original. So if I write my 70% as a decimal, that is 0.7. So the original in reverse percentage, it's what you've got in your total divided by the multiplier. So again, put this in my calculator. I will get 350 divided by 0.7. That gets me 500. So my original number is 500. I've secured some of my marks already. I just need to work out what is 120% of 500. So 120% as a multiplier, that is 1.2. Remember, this is a calculator paper. I have 0 time to do 10% and then increase. So I just need to do 500 and I'm multiplying that by 1.2. Putting that in my calculator, 500 times by 1.2 is equal to 600. And again, make sure you check that the digits you actually entered in the calculator were correct. Under pressure, guys, fingers go all over. That's not us. Beautiful. So we go for the next question. The cost of a ticket increases by 10%, to 19.25. We're asked to work out the original cost. Okay, now I have to reason that if the price increased and is now 19.25, that means 19.25 pounds is equal to 110%. This is an increase. So again, original cost is going to be reverse percentages. So I'm going to write my 110% as a multiplier, which is 1.1. And then all I need to do is 19.25 divided by 1.1 gets me back to the original. So calculator, so 9.25 divided by 1.1, and that gets me to £17.50. Now, guys, I can know if I'm in the range of the correct answer because the cost I now have has to be less, because 110% has to be more than 100. So my cost has to be smaller if the increase is 19.25. Beautiful. We carry on with percentages. We're told that in a cell, a TV is reduced. Notice the language here is a change. So reduced in price by 20%. The sale price is £280. After the sale, the price goes back to the original. Okay? Matt has £340 to spend. Can he afford the TV when it goes back to its original price? Very good question. Let's see what he's up to. So, key point here is to recognize that we have reduced by 20%. So if we have reduced by 20%, I'm thinking 280 in the sale is what percentage? So 100 take away 20 is 80. So clearly, in the sale, £280 represents 80%. Again, I can use reverse percentage to get me back to the original. So 0.8 is my multiplier then. So the original, notice how I like to write what I'm doing. My examiner needs to know clearly my line of thought. So the original will be equal to 280 divided by 0.8. So put that in my calculator. So 280 divided by 0.8, that gets me to 350. Okay, we were told that Matt has 240. Guys, Matt is a day late and a dollar short. He needed to have £10 more. Remember, we need to answer intelligently. 350 is not the answer. The question was, can he afford? We've got to say no. No, he cannot afford it. And then we're going to show our intelligence by saying 350 is greater than 340. Clearly, your line of thought is inked on the paper. We can see clearly how you arrived at your destination, which you did safely. So we go over to Paul. We're told that Paul is completing a pole vault competition. Very applicable. If you love athletics like me, then things like those stand out. So his first vault is 4.5 meters. His best vault, however, is 12% higher than this. Okay? However, his best vault is 10% lower than the winning vault. We're asked to work out the height of the winning vault for full marks. Beautiful. Okay, so I was given his first vault to be 4.5. I was told as well his best vault is 12% higher than this. So I need to work out what it is best vault. So let's go best vault. We are going 12% higher. So that means multiplier is going to be adding on to 100 plus 12, which is 112%. And as a multiplier, that is 1.12. Remember, calculator paper, not breaking down incrementally. We are using multipliers here. So his best volt then will be 4.5, and we're multiplying that by 1.12. Putting that in my calculator to see his best volt, I've got 4.5 times 1.12. That is 5.04 meters. So we finish with that, check that off. Next bit of information here, however, his best volt is 10% lower than the winning volt. So we need to work out what is the winning volt. So this means if it's 10% less than the winning volt, this 5.04 has to represent 90%. Okay, so 5.04 is equal to 90%. So again, reverse percentage can now get us to the winning volt. So 90% is 0.9. So therefore, if I do the original then, which I could call the winning volt, and that's going to be equal to 5.04 divided by the multiplier. So 5.04 divided by 0.9, and that gets me 5.6 meters. And that will be my winning volt. Again, guys, if you have enough time in your exam, you simply have to prove your answers. So if you know this, you can work backwards now and see, do I get the numbers that the question gave me? And that, my friend, is wisdom. Okay, now we go for compound interest. We're told that the value of a house is 120,000. The value is expected to increase by 5% each year. We're asked to work out the expected value after 4 years. Give your answer to 2 significant figures. And that is for 4 marks. Very nice and easy 4 marker there. And compound interest formula is literally handed to you on a platter. So first I need to get what my rate is as a multiplier. So I am going to be doing 5%. So 5%, guys, easy to do on a calculator paper. That is 0.05. I'm adding that on to my current 100%. So my multiplier will be 1.05. Okay, let's put my formula in now for my compound interest. So compound interest is your principal, multiplied by 1 plus your rate, and that's as a percentage to the power of the number of years. But since I know it's 1.05, I can replace all of what is in my bracket with that. So my principal is 12000. Make sure you enter the zeros properly. I'm multiplying that by 1.05, and I'm raising that to the number of years, which is 4. All of my work is now done. I put my calculator to work. 120,000 times by 1.05 raised to the power of 4, and that's equal to 145,860.75. Not my answer. I was asked to give it to 2 significant figures. From the left of my number, I'm counting 1, 2, check. Digit behind can be rounded up. So this is 1, 5, replacing my digits here with zeros. So therefore, it is going to be 150,000. Absolutely brilliant. Guys, drop me a comment. Let me know what you think so far of this revision. And I'm sure you feel more confident than you did before you started watching this video. So in this question, we're told that Mia wants to borrow £6,000 and repay it with interest after 2 years. She sees 2 offers for loans. Mia says, I will pay back the same amount because the average of 1 and 5 is 3. So she's thinking adding 1 plus 5 dividing by 2 will be 3, just as 3 in the first offer. Is she correct? You must show you're working for 3 marks. So first of all, what we have to do is to work out the compound interest in the first offer and also in the second offer, see if they are the same. So we know the formula for compound interest. So in offer 1, compound interest is at 3% per year. Okay, so let's go for offer 1. So formula, principal, we're multiplying that by 1 plus our rate percent to the power of the number of years. Remember, it's 2 years altogether, so it's going to be to the power of 2 when we substitute our value in. So P is what we are starting with, so that's 6,000, and we're multiplying that by, so 3%, that's going to be 1.03, so 100% plus 3% as a multiplier is 1.03. If you're not sure, just do 103% on your calculator and convert that to decimal. So therefore, but what you shouldn't do, we do not accept you put in 103% here. We want the multiplier, okay? So make sure that you do that. So it's 100, 1.03, 103 as a decimal, 1.03. We're raising that to 2 years. Putting that in our calculator, we have 6,000 multiplied by 1.03 and the power of 2. So that's equal to 6365.40. Okay, now let's find out what would be the interest, because remember she says I'm going to pay back the same amount. So pay back, she would be paying back 36540 for this one, and that's in terms of pounds. So 6,000 take away from 6,365.40, which you would have already have in your calculator, will leave us with 6. Notice how I do it. I'm saying the digits. That's what you should do when you're writing it down from your calculator as well. Break it in your digits. So let's go for offer number 2 and then compare them. So offer 2, compound interest for the first year is 0.01, since that's going to be 1%. So we know the multiplier added together with 100% will now be 1.01 for the first year. For the second year, however, it is 5%, so 0.05. And then if we add that to 1, it's 1.05. So we now substitute that into our formula, P times by 1 plus our rate percent to the power of n. We're going to do this in 2 parts this time because the 2 years are different. So it's going to be 6,000 multiplied by first year 1.01. Don't need to put to the power of 1 since it's going to be the same. And then for the second year 1.05. Again, it's just a single year. So we don't need to put the power. If it make you happy, you can put power of 1. Changes nothing really. So let's go 6,000 multiplied by 1.01 times by 1.05. That gets us 6,363 pounds. So therefore, we subtract this from 6,000 from this value. We get 363. So we have proven her wrong. We can see here that what you can do is now to say, is she correct? No, she is not. Make sure you end intelligently. She is not. Okay, and then you qualify that 6,363 is less than 365.40. So they're not the same at all. Okay, a lot of fumbling there from me just now, guys. I don't know why, but let's just blame it on the fact that I'm not 100%. Okay, so we compare them and we make sure that we make a conclusion. Beautiful. All right, so we go for the next question, which is also on compound interest. If you notice, I'm trying to give you all the ways that they could come at you, but for sure, I know compound interest will be there. If you don't see it on paper 2, then it's coming on paper 3, guys. But we don't miss with our compound interest at all. So we're told that Magana decides to put £500 into an account that pays compound interest. She wants to have at least, language here, highlighted for you as well, at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest rate she needs. So in this question, we do not know the interest rate, but we know the formula for compound interest. So as a good mathematician, what I need to do, write my formula down, substitute what I know and solve for what I don't know. But importantly here, we will have an inequality since we're told that she wants to have at least. So that means let's write our formula out and make it either less than or equal to. So greater than or equal to, sorry. So we need to have principal multiplied by 1 plus our rate. So I don't know what my rate is. So guys, let's keep our rate as x in this bit. And that's going to be raised to the number of years. And that now should be greater than or equal to 560. Okay, so I'm going to substitute what I've got. I've got 500 for the principal. That is being multiplied by 1 plus x to the power of 3 years. And that should be greater than or exactly equal to 560. So what I have to do now is to rearrange this to make x the subject, and then I would have found my rate. So rearranging formula and multiplying by 500, I have 1 plus x cubed will be left. If I am going to be doing 560, I need to now divide instead by 500. So doing the reverse of multiplying by 500, I'm dividing. I'm just going to put that in my calculator, keeping this bit here first, and then I'm doing 560 divided by 500, and that gets me 1.12. Now I need to get access to x. I can see that I am cubing. I need to do the cube root of both sides. So I'm doing the cube root of 1 plus x squared. And I am doing the cube root of 1.12. Don't forget to put your cube root. We need to see that. So a cube root removes a cube. So I will now have 1 plus x left on this side. That's going to be greater than or equal to the cube root of 1.2, 1.12. So cube root 1.12, that's 1.0385. Okay, now I need to make x the subject, so I'm taking away 1 from both sides. So x is either greater than or exactly equal to. Do 1 take away from that, gets me 0.0385. Kind of easy to see, guys. I need to get this now as a percentage. So I need to multiply this value by 100. So times by 100. And that gets me to, so x has to be either exactly equal to or greater than 3.85. And that is a percentage. But question says, give my answer to one decimal place. So x then is, the rate would be 3.9 to 1 decimal place. So whenever you finish your question, go back, guys, and look at the degree of accuracy that you should end with. Great. Okay, on to our next question. So the population of a country is now 62,200,000. So let's underline that. The population is predicted to increase by 1% per year for 6 years. Underline. We can also go ahead and put in our multiplier that we're going to need. So it's going to increase by 1%. And then decrease by 1.2. So decrease by 1.2% for 2 years. Work out the predicted population of the country 8 years from now. Give your answer to 3 significant figures. Very important, guys. So let's write our multipliers down, which we can do just beside the words here. So increase by 1%, that's 101%, which is 1.01 for our multiplier. that for 6 years. Decrease, so for this one, we're doing 100 take away 1.2, and then write that as a multiplier. So 100 take away 1.2, so that's going to be 98.8, which is 0.988 as a multiplier. Beautiful. So now we're going to set up our formula. So compound interest, we're going to do it for the 8 years. So we're going to do what we've got for 6 years, what we got for 2 years using those relevant multipliers. So let's go. 6, 7, 2, 1, 2, 1, 2, 3. Make sure we got 5 zeros here. 1, 2, 3, 4, 5. This is what you do because the zeros are very confusing sometimes. So let's go for the first part of it. We're multiplying that by multiplier 1.01. That is for 6 years, so to the power of 6. Multiplied by the decrease now would be 0.988, and that's for the additional 2 years. We're going to put that in our calculator now. So 6720000 multiplied by 1.01 power of 6 times by 0.988 power of 2. So we get 6963,2406.54. Not my answer. I was asked to give my answer to 3 significant figures. So let's go. 1, 2, 3, check. So that means I've got 696. Everything else here now. 1, 2, 3, 4, 5. No, nothing at the end. And that is in terms of number of people. So that is my answer there. Beautiful. Now we go for depreciation. So compound interest is also called appreciation. And when we are going down, we are talking about a depreciation, losing in value. So the value of a second-hand car is £9,000. Each year, it loses 20% of the value at the start of that year. Work out the value in 4 years' time. So again, we are taking away 20%. So 100 take away 20%, that is 80%. So therefore, my multiplier is going to be 0.8. So you get your first mark by putting your multiplier in. Formula remains the same, except that the percentage is now a depreciated value. So again, we know it's P times by 1 plus or minus, in this case, minus. So I'm just going to put my rate in straight away. So 1, take away the percentage this time to the power of the number of years. So it's going to be 9,000. And for the subtraction, we will have 0.8. We worked out our multiplier before, and the number of years is 4. So we put that in our calculator. 9,000 times by 0.8 to the power of 4. And that gets us 3686. Remember, this is money. We must end appropriately. We do not accept 0.4. You've got to recover it to 40 pence. Make sure that you remember that. Money matters. Great. Okay, now we go on to the value of a second-hand car decreases by 12.1% per year. This time we are asked to work out the number of full years until the car loses more than half its value. You must show your working. Okay, guys, so again, we are losing, so depreciation again. So I need to do 100. First step, 100 take away 12.1. And 100 take away 12.1, that is equal to 87.9. As a multiplier, 1, 2 backwards, 0.879. Now, guys, we don't know how much money we're talking about. So a good principle is to start off with 100. So we can say, let the value be 100%. Let the value equal to 100. So we're going to be using that in our formula. Now it's going to be a little bit of trial and error in terms of the fact that we're going to be putting a year in. If the year seems too far away, then we have to keep going. Okay? Now I want it to be half the value. So I'm looking for pretty much 0.5. I'm going to compare halfway, 0.5, 50% of my value, and so on. Okay, so I'm going to start off first of all, because I want it to be halfway, then I know that 1, 2, 3 years wouldn't change a thing. So I'm going to make a judgment, and I'm going to start by doing 100 multiplied by my multiplier, which is 0.87. Sorry, my mouse is stripping. 0.879. I'm going to start off with the power of 5 years and see where I get. So 100 times by 0.879 to the power of 5. That gets me 0.5247. But I want my value to be less than half. Okay? Less than half. So this is 0.5 dead on. So too high. Okay? So next I need to go, I'm going to do, so I can see it's 0.5, but it's not really too far away. So let's try 6 years. So 100 times by 0.879. And you've got this in your calculator, guys. You're just changing the powers each time and see what you come up with. So 100, I was changing my power from 5 to 6. And that gets me 0.4612. So I can see here that now is my first value that will be below half, which is 0.5. So therefore, I can conclude that it is in 6 years. So 0.46 is less than 0.5. Therefore, 6 years. So 6 years is what it will take for that to happen. And you keep experimenting. Remember, 100% is always a go-to, guys. It's always a go-to. So make sure that you start off with your 100%. Well, if you may ask, what if I chose another value? We just want to make sure that we get to a little bit less than half, since it says after how much years will it lose more than half. So we need to get below that half to prove that answer. Beautiful. Now we go on to simple interest. Lots of students mix up their compound interest and their simple interest. So Carolyn invested £700 for 3 years at 2% per annum. Per annum means per year. Simple interest. Work out the total amount work out the total amount of interest Carolyn earned. Okay, guys, so first of all, since we're working out the interest, we can go straight ahead to simple interest formula. So simple interest, this will get us straight to the interest, is equal to principal times rate times by time divided by 100. Or if we wrote our rate as a percentage, we don't need to do divided by 100, which is what I'm going to do. So my starting principal is 700. That's being multiplied by my rate, 2%, which I can just simply write as 0.02. I'm going to put that in my calculator, multiplied by the time, and the time is 3 years. So 700, I'm multiplying that by 0.02, I'm multiplying that by 3. My interest, be careful, the interest is £42. Now, if the question asks you how much she had after, it will be 42 plus what she started with. You have to look carefully. Is it the interest I'm after, or do I want to find out how much I'm at altogether at the end? Okay. Next question says, Nina invested 1,500 for 4 years at 2.2% per annum simple interest. Work out the total money. This is what I'm talking about. Of money, the total amount of money in the account at the end of 4 years. Okay, so I'm going to find out what my simple interest is by using my same formula. Principal times by my rate times by my time. So the rate is always out of a percentage. As I said, we're going to write it as a multiplier instead of dividing by 100. So the interest, the money we start with, principal, 1,500. We're multiplying that by my rate, which is 2.5. We're just going to do 2.5 divided by 100, which is 0.025. And then we are going to multiply that by the number of years, which is 4. Put that now in my calculator. 1,500 times by 0.025 times by 4 gets me 150. That's not my answer. That's the interest. So the total now, would be what I started with, which is 1,500 plus where I'm at now in terms of my interest. I've got my 150, so that's plus 1,500, 1,650. And that is in terms of pounds. And there we have it. So beautiful. We move on from all of those interests and compounds, simple interest and percentages. Let's just review quickly our algebraic vocabulary. Paper 2 tends to come up with a lot of, do the students know these vocabulary? So link the algebra to the correct description. One has been done for you. So we got P equals 3x plus 4y defined as a formula. 3 marks, guys. We cannot afford to give away these 3 marks should they come. So the next one, we have 3x plus 6, and this is the identity symbol. But guys, sometimes this one will come where they don't show you the 3 lines. It could be an equal sign as well, because they are testing if you know what an identity really is as a definition. So we can see if I expand the bracket, I get 3x plus 6, so they are identical. So therefore, that one is an identity, and I've put the line in there to make it nice and neat, so should you. So now, for the next one, I've got 3x plus 2 equals 14. We've got an equal sign there, guys, so we know that one clearly is an equation. This one jumps in too quickly. So 3x plus 2, no equal sign. That is just an expression. And then finally, we have where we have a symbol less than. So 3x plus 2 is less than 14, clearly an inequality. You would agree with me. Very, very easy mark to score right there. 3 marks all in the bag. So we go for sequences, which you could also get to identify your sequences. So match the sequence to the description. One has also been done for you here. So the first one being done is our Fibonacci sequence, where we can see, if you remember the definition in Fibonacci, we also covered this in paper 1 as well, guys. So 1 plus 1 is 2, 1 plus 2, 3, and so on. So each 2 preceding terms add to give the next in line. Okay, we hadn't done all of the numbers, hence the reason I brought this back here. But guys, I cannot stress it enough. You must re-watch part 1 and 2 of paper 1. We have done so much in that is projected towards paper 2 and 3 as well. You owe it to yourself to do this. You have to make sure, because I have not, as I said in the beginning, I have not reviewed in depth the things we have done there, because that's a lot of information for you. All right, so for the next one, we are seeing here, we got 1, 2, 4, 8, 16, 32. We can see that we are multiplying by 2 each time. And by now we know that this is a geometric sequence once we are multiplying or dividing by the same number. So that matches with geometric. For the next one, 1, 2, 3, 4, 5, 6, guys, simply counting by adding 1 each time. So it is our arithmetic sequence. Beautiful. The next one, we got 1, 3, 6, 10, 15, 21. I would imagine that at this stage, guys, we know our triangular numbers. If somebody should wake us up out of our sleep at 3 a.m., we still know them. So here, we're going up by 2, then by 3, then by 4, 5, and 6, and so on. That is our triangular sequence. We all know our square numbers. We've done a lot of work around Pythagoras' theorem where we had to work on our square numbers. So 1, 4, 9, 16, 25 are our square numbers. And our cube numbers, 1 cubed is 1, 2 cubed, 2 times 2 times 2, that's 8, which is our next cube number. 3 times 3 times 3 is 27. So we know that's our cube numbers. Again, very easy marks to score. Make sure you use your ruler. If you make a mistake, find a way to show us what the answers are. What we don't want to see is squiggling lines scribbled out, still drawing from 2 places. No, you have to communicate clearly, even if you're going to use letters to show. But you got to make sure that we are able to see it well and make a professional judgment as to what your answer is. Absolutely brilliant. Now, guys, we go for algebraic proofs. That is very, very common. It could be on paper 2, it could be on paper 3. Regardless of where it is, we will be ready. Will we not? Yes, we will. So we're told here for the first proofs that x is a square number. X is a square number. We're asked to show that the next square number is x plus 2 root x plus 1 for 2 marks. First thing I need to reason here, guys, is that if x is a square number, I want to find out what was the actual number before it was squared. So if x is the number, then the original number has to be the square root of x. So if 9 is the square number, the square root of 9 would be 3. So only because this is now a letter, we still apply the same principle. So the original number before being squared was root x. Now, to get the next square number in line, remember, our first square number is 1. To get our next square number, we have to do 1 plus 1 squared. So in this question, to get our next square number, we're going to need to add 1 to this original number. So it's going to be root x plus 1, but we need to square that. So we will have 2 brackets. So root x plus 1 in one bracket. That's being squared, so root x plus 1. We now need to expand the bracket. So root x times root x, we know by now when we multiply two identical roots, the answer is the number without the root. So root x times root x is x. Root x times by 1 is just root x. 1 times root x, also root x, and 1 times 1 is 1. We just need to simplify. This is a beautiful question because we know the answer we're working towards. So we go here, x. 1 root x plus 1 root x is 2 root x, and then we got a single 1 there. I check, is my answer what it's supposed to be? And the answer is yes. Okay, so for the one person who needs a little clarification, if I started with 1, my first square number would be 1 squared, which is 1. But to get my second square number to the first one, I would now have to add 1, which is 2. Then I need to square that 2. That gets me 4. And that's why we needed to add 1 to root x for the next square number that's going to come, and then square that. So in this question, we're told that x is an integer. What is an integer, guys? Remember, it's a set of negative, positive whole numbers along with 0. Cannot be a fraction or decimal. So we're asked to prove that 35 plus 3x plus 1 squared minus 2x bracket 4x minus 3 is a square number. So the concept is similar to what we have just done on the other question. If we're going to prove that it's a square number at all, we have to be able to factorize and have a square to show that this is a square number. So the first thing up here, we got 4 marks. We've got to expand and simplify. So 35 plus, I'm going to do 3x plus 1. I'm writing 2 of that bracket out since that is being squared. So 3x add 1. I will then need to subtract 2x multiplied by 4x minus 3. So we're going to expand the first set of brackets. So let's put back our 35. So 3x times 3x is 9x squared. Common mistake for students to make is to forget the square. That's not you though. 3x times by 1 is 3x. And then 1 times 3x is also 3x. And 1 times 1 is 1. Let's just expand the other bracket straight away. Pay attention, we got a negative here. So negative 2x times positive 4x is negative 8x squared. On a calculator paper, no excuse for this one. So minus 2 times minus 2 negatives again gives us positive. Don't forget your x because we're doing 2x and 3. So x onto that. Now we need to simplify. So I'm starting with my square terms first. 9x squared, I've got this to be minus 8x here, which will be 9 take away 8 is 1. So that's just x squared. I now have 3x and 3x, that's 6x. Then this is supposed to be positive 6x here. So negative times negative was positive. I think I wrote that wrong. That's not going to be u. So then I need to have 6x plus 6x, which is 12x. And then I've got 35 for my number plus 1, which is 36. Beautiful recovery from me there. Always make sure, guys, I like when I make mistakes sometimes because it shows that you're human, but checking over will help you to get back on track. So now I need to factorize this because remember, I'm trying to show that this is a square number. Hence, I'm looking for two brackets with the same values. So again, we've done this in video part 1 when we were preparing for paper 1. So again, we need to make sure that we remember how to do this. So we need two factors of 36. When we multiply, we get 36. When we add, we get 12. That is 6 and 6. One bracket will be x add 6, the other x add 6. Therefore, both brackets are the same. We do not leave it like that. We write it as a square number. So x plus 6 squared, and then we say to our examiner, therefore, a square. So those 3 dots mean therefore a square number. And there we have it. So make sure you put it in square form. Now, guys, at this point, it doesn't matter the value of x. If x is 1, 1 plus 6 is 7. 7 squared is 49, which is a square number. What if x was 2? 2 plus 6 is 8. 8 squared, 64, also a square number. Doesn't really matter what the value of x is. We will always get a square number. And remember, x will be an integer. Absolutely fantastic. So we move on to this question where we're told expressions for consecutive triangular numbers are n bracket n plus 1 divided by 2 and n plus 1, n plus 2 being multiplied divided by 2. Prove that the sum of two consecutive, so sum means to add, the sum of two consecutive triangular numbers is always a square number. Now, guys, remember the word consecutive means one after the other. Okay, so if the first triangular number is n, the second one for you to get consecutive will be n plus 1 to show that these two numbers come one after the other. But we're given the expressions here and we need to add them together. So I need to do n bracket n plus 1 halves. And that's being added to, because remember it's the sum, n plus 1, and we're expanding a bracket there and then dividing by 2. So let's go ahead and then we're going to simplify. By now we're thinking square numbers. We're going to have the same values that need to be put in one bracket squared. So expanding here, we get n times n, which is n squared, n times 1, which is n, and then we are going to be halving that. So plus n times n is n squared, and then n times by 2 is 2n. N times by 1 is just n, and 1 times by 2 is 2. So we're going to simplify it all. Now, guys, because this is the same denominator, then we can just add all the numerators and then put it over 2. So n squared plus n squared here is 2n squared. And then I've got n plus 2n plus n, that's 4n. And then I have positive 2. I now need to remember to put that over 2. So half of n squared, half of 2n squared is n squared, half of 4n is 2n, and half of 2 is 1. So now I just need to factorize this into two brackets. So I need two factors of 1 that add to 2, which clearly is 1. 1 times 1 is 1, but 1 plus 1 is 2. So one bracket will be n add 1, and the other will also be the same. Remember, we're writing it in a square bracket now. So therefore, n plus 1 squared, therefore a square number. Beautiful. All right, then we go to our next question. Two integers have a difference of 6. Difference mean that when you subtract one from the other, the answer is 6. The integers are multiplied together, and 9 is then added. Prove algebraically the result is always a square number. So let the first number be n. The second number will then be n minus 6. Already get a mark for expressing that. When we multiply them together and then add 9. So we need to do n bracket n minus 6, and then we're going to add 9 to that result. So n times n gets me n squared, n times by minus 6 minus 6n, add 9. Again, we now need to factorize this. So we need two factors of positive 9 that add to minus 6. That has to be n minus 3 and n minus 3. If you look, add them together, minus 3, that's minus 6, but negative times negative will give us positive 9. Again, I now need to write that in a bracket, so therefore square number. Beautiful. Okay, by now, it doesn't matter what they've asked you to prove, this is what you're after. Okay, so if we're proving, for example, a multiple of 3, 3 should be a factor if we factor out 3 outside of the bracket and so on. So we're told here that c is a positive integer. We're asked to prove that 6c cubed plus 30c divided by 3c squared plus 15 is an even number. And if it's an even number, we know that 2 is going to be a factor of that number. So we need to factorize. So again, another opportunity to look at algebraic fractions here. So 6c cubed plus 30c divided by 3c squared plus 15. I'm going to find the highest common factor of 6 and 30, which is 6. And the highest common factor of c cubed and c is c. So outside my bracket, I will have 6c. 6c's times by c squared, it's what gets me back to 6c cubed, plus 6 times by 5 gets me 30. But I don't need c because it's already outside the bracket. So that's for the numerator. Denominator now, highest common factor of 3 and 15 is 3. And then I need to get back to c squared. So it's going to be 3 times by c squared. That gets me 3c squared. And 3 times by 5 gets me to 15. Now I can see I can deliver myself off those two by just cancelling out the bracket. So now I have 6c divided by 3, which is equal to 2c. So I can see that I've got 2c. 2 is a factor of that. So I can end my answer intelligently by saying 2c is a multiple of 2. So 2c is a multiple of 2, or we could say 2 is a factor of 2c, therefore always an even number, or is an even number. Guys, allergies are giving me a hard time, and you know it's very hot at the moment, so I am really actually fighting through to get this revision to you guys. Please make sure that you do your best to go through it thoroughly. Okay, next one. We're told that n is the middle integer of 3 consecutive positive integers. The 3 integers are multiplied to give a product. Remember, product means multiply. N is then added to the product. So after we multiply the 3 of them together, we then add n to the answer. Prove that the result is a cube number. So if we know how to prove a square number, we also know how to prove a cube number. So we know that the middle number is n, which means that the one before, if they are consecutive, has to be n minus 1. And the one after has to be n plus 1. So we're told to multiply these together, and then after that, we will add n to the answer. So we can either choose to do n minus 1 first, and when we get our answer, we times it by the other one. So n times by n is n squared, and n times by minus 1 is minus n. So now we need to times this one by the other bracket. So n squared times n is n cubed. N squared times by 1 is n squared. Then minus n times by minus positive n is minus n squared. And then I've got n times by positive 1, which is minus n. Okay, we can see here that these two cancel out to give us 0 in the middle. So remember, n cubed minus n, but remember we were told to also add n to the product. So this is the product simplified. Now we need to add n to that. This cancels out, leaving me with n cubed. So if n is cubed, doesn't matter what the value is, the answer will always be a cube number. So we could even go ahead and factorize this to say n cubed and then say, therefore, always a cube number. And there we have it. So it doesn't matter what n is, once it's cubed, it will be a cube number. Okay? Okay, so we got some other questions to do on proofs as well, and then we are going to look at iterations. So in this question, we're told that the diagram shows a right angle triangle. We're asked to prove algebraically that x to y is equal to 2 to 3, total of 6 marks. So this perhaps is our first 6 marker that we have seen in this walkthrough. So first of all, it's a reason why they've told us this is a right angle triangle. We have the lengths of sides expressed using variables. Hence, we are thinking Pythagoras' theorem. So we know Pythagoras says that a squared plus b squared is equal to c squared. So we are applying that principle even though we do have expressions. So 6x squared, don't forget to put that in bracket, plus b would be x plus y squared, and that should be equal to the hypotenuse squared, which is 8x minus y, also being squared. So clearly we need to expand all the brackets, and then we're going to simplify. We will try to get a ratio of x to y. So 6x squared is 36x squared. Remember, we're squaring 6, squaring x. For this one, we may need to expand the bracket a bit more by doing x plus y and x plus y. So x times x gets us x squared, and x times y gets us xy. Y times x is also xy, and then y times y is y squared. So let's just simplify that side before expanding the other side. So I get x squared and 36x squared to give me 37x squared. 1xy plus 1xy is 2xy, and I've got another y squared. Okay, let's expand the other bracket now. So I've got 8x minus y and another 8x minus y. So 8x times by 8x is 64x squared. Don't forget your square. 8x times by minus y is minus 8xy. Minus y times 8x also minus 8xy. And negative y times negative y is positive y squared. Okay, so we can also simplify the middle here. In the middle, we will get minus 16. So let me just do that straight away. So 64x squared minus 16xy and a positive y squared. So we can see, to simplify this, we can subtract y squared from both sides. So minus y squared minus y squared. Tidy this up, I get 37x squared positive 2xy, and that's equal to 64x squared, and then minus 16xy. Okay, remember what we want to do is to get ratio of x to y. This is what we were asked to do here. Okay, so we can further simplify this by collecting our like terms here. We can put our minus 16x to the other side. So we will have 37x squared and positive 2xy. This minus 16 will now be positive 16xy, and that's equal to 64x squared. So let's simplify this. We get 37x squared, and this will now be plus 18xy, and that's equal to 64x squared. Beautiful. Now, what we want to do is to get rid of the squares because we need our brackets to be in terms of x and y. Okay, so we have 18xy here. And then we are going to do 64x squared. We're going to subtract 37x squared from that. So we have, let me just put that in my calculator, 64 take away 37, that gets me 27. So 18xy equal to 27x squared. All right, remember we want x to y. So if I divide both sides by x, I will get rid of the square. So I'm going to divide by x, I get 18y is equal to 27x. Now we got them in terms of x and y. We can further simplify. We can divide both sides by 9 to make it simpler. So divide by 9. I will then get 2y is equal to 3x. Now that I've got them in that form, if 2y it takes to make 3 of x, it reasons therefore that y is bigger than x. So the ratio then, x to y, will then be equal to 2 to 3 since y is bigger. So our answer is x to y is 2 to 3. So lots of work there, guys. I tried to do it a step by step. Sometimes you're able to collect like terms and group them even quicker. But for the student who's watching, needs to see every clear step as to how we got the answer. Okay, and so that's how we got our answer in terms of x and y, 2 to 3. Beautiful. So now we go to iterations. Guys, iterations is basically substitution. So it's really not difficult, and you've got your calculator as well. So we're told that an approximate solution to an equation is found using the iterative formula. Xn plus 1 is equal to xn to the power of 3 minus 2 divided by 10 with x1 equal to minus 1. So we always given a starting value. We're asked to work out in part A the values of x2 and x3. So to find x2, first of all, we are going to be substituting the value that we're given to start with into the expression, into our calculator. We can substitute, we can put minus 1 in our calculator first of all, and then save it as an answer. So if you press minus 1 on your calculator and then equal, you will now have saved that as an answer. So when I'm going to substitute it here, I'm going to press the answer button to bring up that answer. So x2 then would be equal to, I'm going to put in bracket the value that I'm substituting, which is my answer. So on your calculator, you will just press ans cubed, and it will already know that the ans you're talking about is minus 1, and then take away 2 divided by 10. You must write the value down for x2. I'm just going to put an arrow there. So put that in my calculator, save it as an answer first. So minus 1 equal. And then I'm going to press on. So fraction button, since we got a fraction here. So fraction button, numerator, ans cubed. Close your bracket before you press the cube. Minus 2 and denominator 10. Make sure you're working along. So you see you should get negative 0.3. Now I need to get x3. Remember, we have already used the answer button. So if you press this again, you will get the next value. However, if you want to, you could just do the same thing and make sure you kept this as an answer, and then it's going to be substituting what we have. But you got to make sure you show the working out. So I'm now substituting minus, and then I'm raising that to the power of 3 minus 2 again divided by 10. And that answer we have been given to be negative 0.2027. Okay, I'll write that better here. Negative 0.2027. And that is my value for my x3. Now we go to see what the next question was. Part B asks us to work out a solution to 5 decimal places. So what we need to do at this stage, because we already have our value in our calculator, if we continue to press the answer button, it will generate the next one in line. So 4, 5, 6, and so on. How I know I have reached the solution is when the digits stop changing. So I'm looking for 5 decimal places. So you're going to press this button until the digits stop changing up to 5 decimal places. So let's do that. So whenever it stops changing up to 5 decimal places, that's when you know you have reached a solution. So I can see here I've got negative. So what you can do also is to write down some of the other values that you get in, like for 4, 5, and then keep pressing, because you wouldn't be able to write down all of them, but write down a few of them. So I've got for part B negative 0.2008 0.97565, but remember I need it to 5 decimal places. So 1, 2, 3, 4, 5, check. I need to round up. So the solution will be negative 0.20081 to 5 decimal places. Okay, as I said, just substitution, not difficult at all for iterations. All right, now, so we go to another question, just a little bit more reasoning demanded here for this iteration. So the table shows values of x and y for y equal x cubed minus 8x minus 10. So we got some values of x and also some values of y. We're asked, between which two consecutive integers is there a solution to the equation x cubed minus 8x minus 10 equal to 0, and also to explain your answer. Now, whenever we are testing if there is a solution to an iterative formula, we are looking for a change from positive to negative or the other way around. Now, if you visualize the Cartesian plane here, if we're saying that this cubic graph is equal, there's a solution when it's equal to 0. If there is a change from negative to positive, so let's say we were here and we're changing from negative to positive. In order for that change to happen, we must have to pass through 0. And dead on to 0 is where a solution would be found. So I'm looking in my table for the values that change from a negative to a positive. And if you look here, when x is 3, my output for y is minus 7. But when x is 4, I have moved from a negative value of y to a positive. So between these two integer values, would there be a solution? So it is x equal 3 and x equal 4. So you're going to say when x is equal to 3, so when x equal 3, then y equal to minus 7. We can see that here in the table. And then when x is equal to 4, y is equal to positive 22. You will then say there is a change of signs from negative to positive. And then say, therefore, there is a solution. Therefore, there is a solution. Okay, so whenever you're asked to check that there is a solution, you're looking for a change from signs, from positive to negative or negative to positive, that indicates that we must have passed through 0, because you cannot get from a negative number to a positive number without passing through 0 on the number line or on the graph. Okay, so next question says, show that the equation x cubed plus 8x equal to 30 has a solution between x equal 2.2 and x equal 2.3. Similar question, different wording. So now we are going to have to put these values of x in and then test to see what are the values of y that is output by this function. So first of all, I need to rearrange this. So I'm going to put my 30 here and make my equation equal to 0. So x cubed plus 8x. And then when I subtract 30, because remember, change side, change signs, that's equal to 0. So now I'm going to substitute when x is equal to 2.2. So we're going to put that into our calculator, but let's write it also down. So we're going to have for x 2.2, that's being cubed, plus 8 bracket, still value of x is 2.2 minus 30. Let's get what our answer is. So 2.2 cubed plus, don't forget to put your cube number in the bracket before cube on the outside, guys, else you'll get a wrong answer sometimes, especially if the value is negative. So put 2.2 in bracket, cubed plus 8, bracket again, 2.2 minus 30. We get negative 1.752. So therefore, if we are expecting for the other value when we substitute 2.3, we're looking for a change in sign from negative to positive. So when x is 2.3 now, I can just go back on my calculator and edit the 2's to 3's, and then 8 bracket 2.3, and then minus 30. So I'm just going to go back, change that, the 2 to 3 in both brackets, and that gets me positive 0.567. We can see clearly in the first one we got a negative answer. The second one is a positive answer. So there is a change in sign. So they say show that this has a solution. Again, you will say there is a change from negative to positive. Therefore, there is a solution. So that's how we check, okay, if we have a solution or not. Beautiful. Okay. All right, now, so we go to last questions on iterations, and then we move on. Okay, so which of the following iteration formula cannot be found by rearranging the equation x squared minus 9x plus 2 equal to 0? So basically, the question could also have just told us, show that it can be arranged to this, or the function in A, or the one in B, or the one in C. So now we're testing which one. Now, straight off the bat, I could see if you look at C, I can see that I do not have any variable onto 2. So there is going to be no possibility at all for us to be dividing by 2 at all, because you can only divide if you've got a variable and the coefficient is 2, but 2 is a constant, so that couldn't be arranged. However, we will have to show some working out. So if I look at A, I've got xn plus 1 equal 9 minus 2. So what I can do is to start with the original formula, rearrange it to give A, and tell my examiner A is possible. So if I have x squared minus 9x plus 2 equal to 0, I can see here that my 9 and my 2 have swapped signs. Therefore, I must have rearranged to have x squared on the left-hand side, and bring in the 9 minus 9x will now be positive 9x, and the positive 2 on the other side will now be minus 2. We can see that this is being rearranged here. Okay, so therefore, what I can do next of all is to divide everything by x. So if I divide by x to make x the subject, I can see here that x squared divided by x is just x, and that's equal to, cancel this out, leaving me with just 9 minus 2 over x. So we know that A is possible. And that's the format that you will take for all of the questions here. So you rearrange them to get the original, okay? So for B, we are dividing by 9. So clearly, we have made 9x the subject for that one. And if that is so, dividing by 9, that's possible because clearly we have a coefficient of minus 9 if we brought that to the other side. So let me just do B as well, and then you would rearrange the other ones for yourself. So if I do x squared minus 9x plus 2 for B, and I want to make 9 my subject, so clearly I would be left with, so let's make equals 0, I will be left with x squared plus 2 on this side equal to, taking this to the other side, 9x. Now if I divide everything by 9, this is what I will end up with. You can see this cancels out, so x then is equal to x squared over 9 plus 2 9s, which is the exact order. So basically, my skill of rearranging formula is what helps me to navigate this question. And then for C, I can also see that, so you see the play on words right there, we are making x the subject, we would find the square root of everything else. So I will do C as well, just in case D as well, just in case they've asked you to rearrange it to make it in this form. So if I want to make 9 will be positive, the 9x positive, and the 2, so that means I'm left with x squared on this side, equal to, I'm taking the minus 9x to the other side, so that will be positive 9x. The 2 goes over as a minus 2. Then to make x the subject, square rooting. So x would be equal to the square root of 9x minus 2. So this is also a solution. So my answer, what couldn't be, is that one, because there's nothing that I can do that makes me divide everything by 2. So C is my answer. Then I'm asked for this question, last one in iteration, show that the equation 3x minus x cubed equal to minus 11, so this one is one where they ask you to rearrange it, can be rearranged to give x equal to cube root of 3x plus 11. So clearly what I need to do, I need to get my x cube on its own. So I'm going to swap sides with minus 11 and minus x cube. So I got 3x. This minus 11 will now be plus 11. And that's equal to, this minus x cube is now positive x cube. To get x on its own, I need to do the cube root of both sides. So therefore, this is going to now be x equal to, so cube root of x cube is x, and that's now going to be equal to the cube root of 3x plus 11. Sometimes questions will say, by rearranging this equation, create an iterative formula. And this is what you would have done. After creating the formula, they may ask you to go ahead now, find x1, x2, x3, and then by extension, is there a solution? Remember, key factor here, if there is a solution, there has to be a change of sign from positive to negative or vice versa. That's what we are after. Absolutely fantastic. So we've looked at iterations. Now we move on to some proportional reasoning. We're told here in question 1, a building company employs 2 laborers, 4 joiners, 9 electricians, and 8 plumbers. For a job, the company need 1 of each type of worker. Part A asks us, in how many ways can the company choose the 4 workers? This is the product rule for counting, but we still fall under proportional reasoning. So we know this is the simplest product rule you could find. And if we need 1 of each, that means all we need to do is to do all of the variables multiplied together. So I've got 2 laborers multiplied by 14 joiners multiplied by 9 electricians multiplied by 8 plumbers. Put that all into my calculator. 2 times 14 times by 9 times by 8, and that's equal to 2016, 1 day in the past, 1 year in the past. Beautiful. So that is part A. We go to part B. Part B says 1 laborer and 2 plumbers are on holiday. In how many ways can the company now choose 4 workers? So let's go. 1 laborer, laborers going down by 1. So the new one we're going to use for that is 1. 2 plumbers are also away. So plumbers going down to 6. Still the product rule, but with the new variables. So it's going to be 1 for the laborers, multiply all joiners still there, which is 14, all electricians still on site, which is 9, but the plumbers have gone away by 2, so now that is 6. Again, put that back in our calculator. It's 1 times 14 times 9 times by 6. Now the possibility has deduced to 756 different ways we could combine them all. Fantastic. So now still on the product rule for counting, a very, very poorly done topic across exams, especially depending on the context of the question. So the first question here told us that Tom picks a 3-digit even number. 3-digit even number. So we're looking that the last digit has to be a multiple of 2 or divisible by 2. The first digit is greater than 6. the second digit is less than 7. Okay, how many different numbers could he pick? A good practice here is to write out our numbers. So I'm going to write 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we've got our possibilities there. So let's go for first digit, second digit, and third digit. So we always get them by the digits and we do one at a time. So we're told that the first digit is greater than 6. So digits greater than 6 are these three. So there are three possibilities for the first digit. Remember, it's the product rule. So we're going to multiply the possibility of first digit by possibility of second by third. So tick that off. We've done that. It's the clear logical thought that makes this question comes through for you. The second digit is less than 7. So we need to count all the digits less than 7. 1, 2, 3, 4, 5, 6, 7 possibilities. We write that down under the second digit. The third digit, however, was not given, and that's because we've got to use the concept that if it's an even number, it has to end either in 0 or other even numbers as well. So let's pick out all the even numbers along with 0. So I'm going to put a star. So 1, 2, 3, 4, 5 possibilities of ending. So multiply third digit, 5 possibilities. So 3 times 7 times by 5, and that gives us 105 different numbers. See, really not difficult. One criteria at a time, guys. Really that simple. Next question says, Amy and Becky each make integers using 3 single digits, highlighted for us there. In any integer, digits may be repeated. So again, possibility here. You have to look whether the question say we can repeat or numbers cannot be repeated, because that will influence the total we're working from. We're told that Amy makes even numbers. So even integers with the first digit greater than 7. Becky makes odd number integers, so odd for Becky. First digit that is non-zero. So non-zero means digit that is not a 0. So it has to be 1 and above. Okay. How many more integers than Amy does Becky make? So we first of all need to work out for each girl and then make the comparison. So again, let's write down our numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Amazing. Let's go for Amy's criteria first, and then we'll do Becky's after. So Amy makes even number. So 3 digits. So let's write first digit for her, second digit, and third digit for her. Okay, so she makes even integers with the first digit greater than 7. Let's sort out the first digit. Greater than 7 is 1, 2. So that's the first digit for her is 2. The second digit had no criteria. So that means all possibilities. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities for the second, but she's making even numbers. So we need to count the even numbers. Don't forget 0. Okay, so it's 1, 2, 3, 4, 5 possibilities. I'm using my calculator for every step of the way, guys. So 2 times 10 times by 5, that gets me 100. I know some people, oh, that's easy. No, under pressure, you will make mistakes. Now let's go for Becky. So Becky, and we're going to follow her criteria. First digit, second digit, third digit, just like we did. So Becky makes odd numbers. We know the last digit has to be an odd number with a first digit that is non-zero. So 0 cannot be involved at all. Okay, so every number except for 0 is a possibility. So that means there are 10 numbers. 9 will be the possibility for her first one. Second digit had no criteria, so that's still going to be 10 options. Third digit has to be odd. So odd number 1, 2, 3, 4, 5 possibilities as well. So 9 times by 10 times by 5 gets me 450. And now to answer the question, how many more integers than Amy does Becky make? Just subtract them. So 450, take away 100. That's an easy one, guys. 350 more. So that's our answer there. Do you agree that the product rule for accounting is not that bad after all? We have a few more to do, especially the very tricky ones, and based on data, most students got this wrong. Okay, so we're going to move on to our next section. So now we're going to do our final question on the product rule for counting. We're told in this question that Liam is trying to remember a 3-digit code. So I'm going to underline that. He knows the rule that the first digit is a cube number. So underline cube number. The second digit, so second digit is a factor of 16. Very important information. And the third digit is an odd number. Liam tries at random a code that matches the rule. Work out the probability, underline probability, that this is the correct code, and that's for 4 marks. Okay, so the first thing that we need to do is to write out all of the digits that we should have. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now we're going to do first digit, second, and third. So we're told the first digit is a cube number. So let's write down all the cube numbers that we have in this list. So the first cube number is 1. Second cube number is 8. So clearly there's only 2 options from that list. Then we need the factors of 16. So we go 1, we got 2 as a factor, 4 is a factor, and 8. So we only have 4 options for that. And the third digit is an odd number. So 1 is odd, 1, 3, 5, 7, and 9. So that is 5 options. So 1, 3, 5, 7, and 9. A very good practice, guys, is to list the possibilities. So now that we know that, we can find out the total possibilities altogether by doing, first, we got 2 options for the first digit. That is being multiplied by 4 options for the second, and then there are 5 options for the third. So 5 times 4, 20 times by 2, that is 40 altogether. However, the question asks us to work out the probability that he gets the correct code. So if we look, possibility is for the first option, he has 1 out of 2 chances to pick the right code. For the second one, he's got 1 out of 4 chances to pick the right code. And for the last one, he's got 1 out of 5 options. So all we now need to do is to multiply. 1 times 1 times 1 is 1. And then 5 times 4 is 20, times by 2 is 40. So he's got 1/40 of a chance to find the right code. Beautiful. So now we move on to parts of the circle. This comes up a lot on either paper 2 or 3, guys. And sadly, lots of people don't know the parts of the circle. So I just decided, let's revise that. So we're given some words here, and we are asked to label the parts of the circle shown in the diagram. So for the first one, part A, we can see it is the distance all the way around. I hope you could see that animation with the shimmer of the circle. So we know all the distance around is our circumference. So I'm going to tick that off from my list. Part B is our chord. The part B, from one end of the circumference to the other, doesn't pass through the center at all. That is our chord. This is poorly known by students as well. So part C is one, that is our radius from the center of the circle. So the radius and the diameter are the most 2 common ones. Students really do know those ones. So C is our radius. We go for D. D is poorly known as well. So this is a part of the circle. It's bounded by a chord. So remember, a chord goes from 2 parts of the circumference, not going through the center. So it's bounded by a chord, and this bit here, which is an arc, that is your segment. We always mix up our sector with our segment. Part E, we can see clearly that is the center of the circle. So we put that in. Then we are at F. Most of us will know F as well, and that's because we work on tangents of circles. So F is our tangent. Make sure you know these guys. So G, this is the one we mix up with the segment. So this is like the slice of a pizza. Slice of a pizza is our sector of the circle. So don't mix up your segment with your sector. Now, talking the language helps, guys. Instead of saying, can I have a slice of the pizza? Say, may I have a sector of the pizza? And that helps you to remember it as well. So H, clearly, that goes through the center of the circle. That is our diameter. And finally, a part of the circumference is an arc. And we could have a minor arc, which in this case, it's a minor arc for I because it's a small arc. And if we had considered the bigger part, it would have been a major arc. So just a quick reminder there. Now we are going to go to our trigonometry, but we're going to look specifically, first of all, on SOH CAH TOA. Now we've got our calculator. Don't have to worry about exact trig values at all. So we are told here to use trigonometry to work out the value of x for 3 marks. And that's for these 3 questions. So first step, we always go to the angle when we are going to label our sides. We stand at the angle. We can see here that we do not have the opposite. The opposite faces the angle. We don't have the opposite. We've got the hypotenuse, which is the longest side, and the side we want to find is the adjacent. So we are looking for the ratio with AH, and here we can see it's cos. So we're doing cos 28 is equal to, remember, A comes first in the formula, so it's x first, divided by the hypotenuse, which is 8. Now, easy way to know if you're multiplying or dividing, which is a clear way to do it, is put this over 1. Then 1 multiplied by x is x. So now I will see I'm also doing cos 28, put that in bracket, guys, multiplied by 8. Remember, when you're putting this in your calculator, you make sure you check your calculators on degrees. If you don't, you're going to get an answer, but the answer is going to be wrong. So when I put this in my calculator and do cos 28, I must close the bracket first before I press multiply by 8. So therefore, that gets me 7.06 to 1 decimal place. We make sure we look to see if the question tells us what we should round to. If not, we're free to do so. But you can see I've specifically told my examiner that I've rounded. So this is the 2 decimal place to 1 dp. It's going to be 7.1. Okay, so whatever it is, check and make sure. For the next question, I am standing at my angle first. I can see I am trying to find my opposite side. I'm not at all given the hypotenuse, so I have been given the adjacent side. So I'm looking for a ratio OA. OA is tan. So tan 31 is equal to, the opposite is x, that goes on the numerator, and the adjacent is 13. So again, put that over 1. I can see 1 times xx. Then I'm going to do tan 31, put that in bracket, and I'm multiplying that by 13. Put that into our calculator. So tan 31 times by 13, and that gets us 7.8 centimeters to 1 decimal place. Over to the next question. We're asked to use trigonometry to work out the value of x. So again, going to go to the angle. Labeling across is the opposite. I have been also given the hypotenuse. So I want ratio with OH. OH is sine. So sine 41 is equal to my opposite, which is x, divided by 19. Again, put over 1 times xx. So essentially, I'm doing sine 41, which I put in bracket, times by 19. Clearly, guys, if the letter is on the top, we see we are multiplying. If the letter is in the denominator, we are dividing. Remember that. So sine 41 multiplied by 19, we're going to keep that to 1 decimal place as well. So that is 12.5 centimeters, and we are done with finding sides. Absolutely brilliant. We move on, still finding angles this time with SOH CAH TOA. So we're asked to use trigonometry to work out the size of the angle this time. Same principles apply. We go to the angle and we are going to label the side that we're given. So in this case, we have to know two sides if we're going to use trig to find the unknown angle. So I can see here 9 is the opposite, and we also have 11 to be the hypotenuse. So OH, we are using sine. So we go for sine x, we don't know what it is, equal to my opposite side, which is 9 divided by 11. We know when we're finding an unknown angle, we are doing the inverse function. So x then is going to be equal to sine inverse. On your calculator now, you are pressing the shift or second function and then 9 divided by 11. So sine inverse 9/11. And that gives us, I'm going to also do that to one decimal place, that's 54.9 degrees. And we check that off. Over to the other question, we're finding also another angle. So we stand at x. We can see here we have opposite, and we have not been given the hypotenuse at all. So we have been given the adjacent. So OA is tan. So we're doing tan x is equal to the opposite side, which is 8.8, divided by the adjacent, 4.5. Common mistake is to swap the sides around. Make sure you write your SOH CAH TOA down and you substitute directly into that. So again, we're going to be doing tan inverse. So x will be equal to tan inverse of 8.8 divided by 4.5. We put that in our calculator, shift and tan. And then 8.8 divided by 4.5. Going to do that to 1 dp. That is 62.9 degrees. And just like that, we've done our sides, done our angles. We know SOH CAH TOA tends to come up a lot. So we go now to sine and cosine rule. We're asked here to work out the size of angle x. So remember, if it's a non-right angle triangle, we're either using sine rule or the cosine rule, but we need to check criteria. Remember, in order for us to use the sine rule, we must have a matching pair, and that means we must know a side and its matching angle, or we know an angle and we don't know the side, or the other way around. So if we check here, we look for, do I have a matching pair? I do. I've got the angle 77 and I also have the matching side 20. And then I can find x because I know its matching side. So we know clearly for this question, we are using the sine rule. And we're finding an angle, so we're going to put sine A over little a is equal to sine B over little b. So now we're going to substitute. So sine 77, and a common mistake in these questions that we see every year, people forget to put the sine. They put just the angle. So sine 77 divided by 20, which is the matching side here, is equal to sine x, don't forget your sine, divided by 14. So now we need to solve this by cross multiplication. I'm going to do 20 times sine x, which is 20 sine x, and that's equal to sine 77 multiplied by 14. Again, make sure that you put in bracket what you're doing here. If you don't, your calculator is going to find the sine of 77 times 4. That's not what we want. We want the sine of 77 and that answer multiplied by 14. Beautiful. So now we're going to multiply. So if I do, divide first of all by 20 on both sides. So sine x is therefore going to be equal to, let's put that in our calculator. So sine 77 multiplied by 14 and then divided by 20. Again, use your fraction button for this. We get 0.68205. Take your time, make sure you copy this correctly. So x then is equal to, remember, we now have to do the inverse of sine when we're finding an unknown angle. So x is going to be equal to sine inverse of the answer. I'm just going to put answer here. You need to store the answer in your calculator, especially for long digits, and just do sine inverse and press the answer button. You will get the actual answer you're looking for. So therefore, x then is equal to, just going to press, and that is 43 degrees. Okay, make sure that you check your answer properly. Now we go to this question for 5 marks where we're told that ABC is a triangle. ABD is a sector with center A. So we check our diagram. We see ABC here. We also see the sector there. We're asked to work out the area of the sector ABD. So we need the area of this sector here. My first thought is to write down what is the formula for the area of a sector and then check to see, do I have all the components of the formula? So area of a sector is theta over 360 multiplied by pi r squared. So basically, I'm trying to find out what fraction of a full circle is this sector. So first question, do I know the radius? I do. So the radius is the length AB here, which is 9. But do I know theta, the angle? Absolutely not. I don't. But I have enough information, so I need this angle here. So I'm going to call it x and then see how we can find that. So using the triangle ABC, we can find what x is by applying the sine rule. So again, do I have a matching pair? I do. I've got 32 degrees and I've got the matching side of 9. And I want to find the angle x. And I also have its matching side, which is 15. So again, I'm going to set this up, angle. So I'm going to do sine 32 over its matching side, which is 9. And that's equal to sine x, which I want to find, over 15. So same principle apply. 9 times by sine x is 9 sine x. And that's equal to sine 32 multiplied by 15. Again, I need to divide both sides by 9, making sine x the subject of the formula. So sine x then would be equal to, if I cancel this out, I'm going to just put that in my calculator now. So sine 32, remember, close my bracket. I'm multiplying that by 15 and dividing that by 9. I get 0.883198, which I'm now going to save as an answer. Makes it so much easier. I know I have to do the inverse function. So x then will be equal to sine inverse of my answer. It's okay to write answer there, or you can also write it out. So I just need to now do sine inverse and then press answer here. And my answer is equal to 62 degrees. So now, and again, guys, good practice, we write this on the diagram to close the gaps in the question. So now I have all the components I need to find the area of the sector. And you will agree why this is worth 5 marks altogether. So now I know the angle. I'm going to substitute that in my formula I previously wrote down. So theta is 62. So 62 out of 360 multiplied by pi, multiplied by my radius, which is 9. And don't forget to square your radius. It's pi r squared. Put that in my calculator. Press your fraction button. 62 on the numerator, 360 denominator. Go across, multiply by pi times 9 squared. And I get 43.8. And that is centimeters squared. Don't forget your unit as well. So that is a question that interleaves the sine rule along with the area of a sector. Brilliant. Now we go over to the cosine rule. Now there will be nothing in the question that will tell you which one to use. So you got to get the mathematical dialogue going. So is this a right angle triangle? The answer is no. Do I have a matching pair? The answer is no. So I cannot use the sine rule at all, but I have two sides and the angle in between them. If that is so, I can use the cosine rule. So let's go. So for this question, I'm asked to work out the length of the side x. So I need to write down my cosine rule. Now, guys, a lot of people mix up which side is A. A is always the side that you have along with the angle. So this one, X is what I want. That's little a, and this is my angle, big A. Doesn't matter which one really is A, B, and C. So let's go for the cosine rule. We know the cosine rule states that A squared will always be equal to B squared plus C squared minus 2BC cos A. I think you're given this one on the formula sheet nonetheless, but a good practice is to know your formula, know it inside out. So now we're going to substitute. A that we're trying to find is the X on the diagram. So X squared is equal to B squared. I'm taking B to be 6.2 plus C squared, which is 6. That's being squared. Take away 2 times by B, which was 6.2, times by C, which was 6, and then multiplied by cos, and the angle given is 54. Nice and easy on a calculator paper, guys. I am just going to put this all in my calculator, get a value, and then square root that to get what X is. So let's go for it. So I'm doing 6.2 squared plus 6 squared, take away 2 bracket, make sure you put all of this in bracket, 6.2 times by 6, then times cos 54. So X squared will be equal to, I got 30.708777, and I know I have to do, I'm going to save this as an answer as well, and then here X would be equal to the square root of 30.708777. So, but I will just press square root of ans, and then my answer is 5.54 centimeters. Guys, we know the place is really hot for the last few days. I'm telling you, I can feel the heat, man. Okay, guys, so let's keep going. So work out the size of the angle X. So this time we are working an angle. Now, a good way, we know how to rearrange to make different variables the subject of the formula. So to save you all the trouble to substitute into the first formula that we wrote down here, a good practice is to rearrange it to find what is the angle formula. So that is how I teach it when I'm teaching it in my classrooms. We just rearrange it and always substitute directly. So this is what we need to do. So since we're finding an angle, we are literally finding cos A. So cos A is equal to B squared plus C squared minus A squared divided by 2BC. Beautiful. So once we know this, we are substituting directly into this, gets us straight to our answer. So we don't know what A is, so let's keep going. We're going to substitute this. So cos A will then be equal to B squared. Remember, A is the matching one to the angle, so A is the 10. So let's label that. So 9 squared plus 3 squared, take away 10 squared, divided by 2 times by B, and our B was 9, and our C is 3. Put that all in our calculator now. Remember, this is an angle, so we're going to need to do the inverse of cos at the end. So we put that in our calculator. So we've got, press our fraction button. On the numerator, we're going to do our 9 squared plus 3 squared minus 10 squared. Denominator, 2 times 9 times by 3. That gets me negative 0.18518518. I'm going to save that as an answer. So A then would be equal to cos inverse. I'm just going to write ans here. Cos inverse of the answer. And that gets me 100.67 degrees. Beautiful. You can see how much easier that is than to substitute into this first formula and rearrange for the angle. Just rearrange it straight away. Absolutely fantastic. We're doing well so far. So we're going to do this question. We're told that ABCO is a sector with a center O. We observe the diagram. We see the sector there. D is a point on OC. So we can see OC here, and D is a point on OC, so that O to D OD to DC is 5 to 3. That's the ratio that this is split into. OA, which is a radius of the sector, importantly, is 24. And AD here, which is just a code, is 36 centimeters. We're asked to work out the area of the sector. So a little bit of ratios integrated into this one, a 5 marker, nice and easy 5 marker here. So again, I'm thinking, how do I find the sector of a circle? It is theta over 360. So the area of the sector, A, is equal to 3 theta of 360 multiplied by pi r squared. I check, do I have the angle given here? No, I don't know the angle. So let's call that x. We will need to find it. But I now need to use my ratio parts here to get the dimensions on the first triangle here and ultimately the latter part of the sector as well. But I know OA is a radius, so OC also is a radius. So that means I can split 22 centimeters into two parts, into the ratio 5/3, 5 to 3, and therefore I will know the length that I want there. So let's do 5 plus 3 is 8 ratio parts. 24 divided by 8 is 3. Again, use your calculator, guys. So therefore, for the 5 parts, which is OD, it will be 5 times by 3, which is 15. So this bit is 15. So we put that there. And then for the 3 parts, 3 times 3 is equal to 9. We check 15 add 9 is 24. So DC is 9. Now I have enough information to find the angle. And again, I can see I'm using the cosine rule to do that because I do not have a matching pair, but I have A, B, and C. So I'm going to be using my formula cos x will then be equal to b squared plus c squared minus a squared divided by 2bc. Okay, so we're going to substitute now. Remember, our A is the matching side for the angle. So therefore, cos x would be equal to 24 squared plus 15 squared, take away 36 squared, and then all over 2 times by 24 times by our 15, and that's the BC there. So we'll put that in our calculator. I get, so 24 squared for my numerator plus 15, take away 36 squared, denominator 2 times 24 times 15, all of that gets me -0.685. So that's what cos x is equal to. So x is equal to cos inverse of the answer. I'm just putting that there for the interest of time, but you can copy that back. And that gets me 133.432, which I can save as an answer to 5. I can save that as an answer. Now I've got enough information. I'm substituting the angle 133.4. I'm putting that in my formula now that I wrote here. So 133.43 ... divided by 360 multiplied by pi times by my radius. Remember, my radius is 24. So 24 squared. Put that in my calculator now. 133.4. So I've saved that as an answer. So I'll just do answer divided by 360 times pi times 24 squared. And I get 670.7 centimeter squared. Absolutely brilliant. Guys, you can see here that it's not really difficult at all once we break it down into small, manageable steps. And just like that, you scored that 5 marks. So in this question, we're going to be looking at area using sine. So 2 sides of a triangle are measured to 1 decimal place. Point of information. Once we hear that, we're thinking of bounds, guys. So to 1 decimal place. The angle between the sides is measured to the nearest degree. Again, bounds. work out the upper bound. See, I knew that before I even read that. You've got to make sure you can identify when intervals come into place. So work out the upper bound of the area of the triangle you must show you're working. Again, I am checking. I've got an angle, I've got the two sides and the angle included. I know I'm applying error intervals to this question, and also this is not a right angle triangle at all, so I must be using the area using sine formula. So I'm going to write that down straight away. So I know that when I have the area for a non-right angle triangle to be found, it's going to be half AB sine C. I write that down straight away, give myself that clear logical thought. So now I've got to focus on my bounds, since I was told that these sides is measured to the nearest 1 decimal place. And I want the upper bound. So I need to write down the bounds. So the lower bound for 17, so let's do 7.2 first of all. So the lower bound would be 1 here. So we know it's the 1 decimal place. So we're adding and subtracting 0.5. So if I take away 0.5 from 7.2, that's going to be 7.15, and the upper bound then will be 7.25. I also need to get that for 13.6 as well. So 13.6, we know the upper bound is going to be 13.65, and the lower bound would be 13.55. I've got my intervals. Now for the angle, I've got to be careful. It's to the nearest degree. So that means 110, the upper bound for 110 would be 110.5, and the lower bound would be 109.5. I've got all of that down. Now I've got to be careful as to what I'm using. Now, it's straightforward for the sides of the triangle because I'm doing the upper bound. I've got to take the upper bound of both of the sides. However, for the angle, even though the upper bound here is 110.5, I cannot use that. I have to use 109.5. The reason for that is once sine is above 90 degrees, when the angle increase, the sine decreases. So the lower the sine, the bigger the value I will get from sine. So I've got to use the lower bound for this one to get the maximum for the angle. So now we've got all the things we need. We're going to substitute this in the formula now. So it's going to be half A upper bound 7.25 times by B upper bound 13.65, and then multiplied by sine, and we're using 109.5 to get the maximum value for the angle. From here, we just need to put this in our calculator. So it's half times by 7.25 times by 13.65 multiplied by sine 109.5. Remember to press your sign, guys. So the answer then is 46.3 centimeters squared if we are doing that to 1 decimal place. So let me just verify that. So to 1 decimal place, 46.6. Make sure that you fact check that. Once you put that in your calculator, you should get 46.6 to 1 dp. And remember, the reason we had to use the lower bound for sine, anything over 90 degrees, we will get a maximum value using the lower value of sine. Beautiful. All right, we are moving on. Now we have this question involving a little bit of bearings here. So we're told that both A and both B leave the port P at 12 p.m. So underline the time that it left. Both A travels on a bearing of 112 degrees and travels at a constant speed of 16 miles per hour. Both B travels on a bearing of 220 degrees and travels at a constant speed of 14 miles per hour. At 2:30 p.m., what is the direct distance between the two boats? And this is for 5 marks. So we left at 12. We want to know what is the direct distance at 2:30 p.m. between these 2 points. Now, a good practice, guys, is to sketch a diagram. So we know they are both leaving from port P. So I'm going to establish my starting point here, put my bearing, my north line in here, and A is found on a bearing of 112. We don't expect you to draw this accurately. You're basically estimating. So I know 90 degrees is across, straight across. So 112 will be somewhere around here. So I'm going to put 112 degrees here, and this is A. Now, I know that the speed at which it travels is 16 miles per hour, okay? But I need the distance here because I cannot calculate the direct distance unless I know the length of the side of my triangle that will be formed. So I can use the information given here. I know that distance is equal to speed multiplied by time. So I know the speed is 16 for both A. So multiplied by, I now need the time. So I need to see if from 12 to 2:30. So from 12 p.m. to 2:30, the time is going to be 2.5 hours. You can put that in your calculator and make sure you get that 2.5. So 12:30, and I left at 12 to 2:30, sorry, that's 2.5. So now I need to multiply 16 by 2.5 to get the distance here. Put that in my calculator. So 16 times by 2.5, that is 40. So that will be 40 miles. So we put that in on our diagram there. So we check that off. We've gotten the information for that bit of the question. I've got to do the same thing for boat B as well, but it travels on a bearing of 120. So I know from north here, 180 is straight along. 120 is going to be somewhere here. And that's where boat B is. Now, be careful. From north all the way around here will be 220. Let me slow my roll. It's 220. I know out of that 112. So I need to do 240. I keep saying 240. 220 take away 112. Let's put that in our calculator. So 220 take away 112, and that gets us 108. So this is 108 then. So altogether, it's 220. Beautiful. So what I need now is to get the distance as well. We know both of them goes and stop at 2:30, so the time is the same. The speed, though, for boat B, so let's work out that. So boat B, the boat for B is going to be, the speed is 14. So I'm doing 14 times by the time, which is 2.5. So 14 times by 2.5, and that gets me 35. So the distance here is 35. Okay, now they've asked me for the direct distance between boat A and boat B. So I'm trying to find this bit here. Now I can see I have got this triangle here. So again, I know 40, I know 35, I know the angle between them. I'm trying to find that. So clearly, I am using the cosine rule for this. So I know that x squared is going to be equal to, let's write 35 squared plus 40 squared minus, so let me write the formula. A squared is equal to b squared plus c squared minus 2bc cos A. And guys, I want you to write the formula when you get into your exam and substitute directly into it. So I've just hold my brakes and make sure I model what I want you to do. So 35, 40, 2 times by 35 times by 40 times by cos. And the angle that we have here is 108, so cos 108. Now we're going to put that in our calculator. So 35 squared plus 40 squared, take away 35 times 40 times by cos. Don't forget to press cos, 108. So x squared will be equal to 3690.247584, which we can save as an answer as well. So we know that we are going to now need to do the square root to get x on its own. So square root both sides. I will have x equal to, I'm going to just put the square root of the answer I got there, which you will have on your calculator, and that is 60.7. So the direct distance is 60.7. We know our units is usually just provided on the answer line as well. So again, interleaving. So bearings being interleaved with speed, distance, and time, which is interleaved with cosine rule. And that is the difference between a grade 8 and a 9 question. And this is the difference between you getting a 7 up or something below, which we don't do. Beautiful. All right, so we are moving along. Now we are looking at Pythagoras and trigonometry in three-dimensional shapes. So we're given this question here, a nice cuboid. We can see it's a cuboid based on the linear components. We got 12, 15, and 5. We're asked to work out the length of the diagonal AB, and a cuboid dimension is 5 centimeters, 12 centimeters, and 15, which we read from the diagram, for 3 marks. So guys, we know how to use Pythagoras' theorem on two-dimensional shapes. We are applying the same principles when it comes to three-dimensional shapes. All we have to do is to split up our 3Ds into 2Ds, and we are on our way. So I want to find the length of the diagonal AB. I need to establish a right angle triangle. So I'm putting a triangle here. I can see this is my triangle. I've got the length 5 here, but in order to find AB, I need to find the side from A all the way over to this side. So this length. If it helps you, you can also take the triangle off in a 2D and make the triangle there. So I'm trying to find AB, which is that side. I know 5. From this triangle here, which is another right angle triangle, I need to find the hypotenuse here. And the hypotenuse here, is my short side for the one I really need. So I've got to use 12 and 15 to find this hypotenuse, which I'm going to call y. So let's go. We know Pythagoras' theorem states that a squared plus b squared is equal to c squared. Beautiful. I'm trying to find the hypotenuse, hence I'm doing 15 squared plus 12 squared. And that's going to be equal to my y squared that I just established. I can just put this all in my calculator, guys. So I'm going to, essentially, y will be equal to the square root of 12 squared plus 15 squared. Just going to do that all at once. So square root of 12 squared plus 15 squared. And that gets me square root of 369. Now, I'm not going to simplify that just yet, and that's to preserve accuracy. Now, when I'm going to use a value again, it's a good practice to keep the raw surd form so I preserve the accuracy. I want to stay within the boundaries of the mark scheme. So I'm going to write this in terms of root 369. Okay, now I've got the information there. I have enough information to find the side I was asked to find. So let's put this on our 2D that we did. Again, I'm finding the hypotenuse. So we're going to do another Pythagoras theorem on this one. So therefore, x squared will be equal to, I can go ahead and say, square root of 369 squared, that's my side there, plus 5 squared. Again, I can put this all in my calculator. Once I've written this down, x then will be equal to the square root of the root of 369 squared plus 5 squared. Get my answer straight away. Once I've documented this, I will score all the marks I need to have. So therefore, putting that in my calculator, square root of, in bracket, the square root of 369 squared plus 5 squared. To 1 dp, I get 19.8 centimeters. And there we have it. Beautiful, nice 3 marker there. We are moving, guys. We are moving. So here we got another question. we're told a tower is located at the corner of B of a rectangular field ABCD. AB, we're told, is 20, guys, let me slow down. AB is 80 meters. So I'm going to put that in straight away on my diagram, 80. Beautiful, tick that off. And AD is 120. So A to D is 120. Label on my diagram, check that off. The tower is 20 meters tall. So this is my tower at EB, and I'm putting my 20 there as well. Now we're asked to calculate the length of DE. So make sure you make that connection. This is the length I want to find. Clearly, I will have to establish a right angle triangle here. Okay, now I have just a part of the information that I need to find the length. So let's call this X. That's what I want to find there. I have 20 here, but I need BD in order to be able to complete the set for the lengths I need to use. So I can find this out because I know this triangle at ABD, and I know 80 and I know 120. So essentially, I'm finding the hypotenuse on this, which actually will be the base of the triangle I really want the dimensions for. So let's go and find what is BD in terms of y. So y squared, hypotenuse, would be equal to 80 squared plus 120 squared. Essentially, I can just do that. Y will be equal to the square root of 80 squared plus 120 squared. So we're going to put that in our calculator. So square root of 80 squared plus 120 squared, I get 144.222. Okay, so that would be the measurement here. Again, you could leave that in its exact form since you're going to use it. If not, you need to do at least 3 decimal places to preserve the accuracy. So now that I've got that information, I can go ahead and find DE. So DE squared will be, again, the hypotenuse would be equal to 20 squared plus 144.222 squared. Again, DE then would be equal to the square root of, using my calculator to my advantage, I don't have to break things down, especially this is 3 marks. I can just go ahead and put this all in at the same time once I've documented this to get an answer. So the square root of all of that gets me, so root of this would be 200, or if I went straight from here to the end, I get 145.602, and that is to 1 decimal place 1.45.6 centimeters, or meters. It is meters. So that's my answer. Okay, to 1 decimal place. Question didn't tell me what it wanted me to use, so I'm free to do what I want to round to. Just make sure that you state what it is. Okay, another question this time, asking me to find the volume of a cuboid this time. So the length of an internal diagonal of a cuboid is 18. Okay, so the diagonal, let's put that in straight away. That's 18. The diagonal makes an angle of 26 with the base. Okay, the area of the base is 160 centimeters squared, and we are asked to work out the volume of the cuboid. Now, key information here is to write the formula for the volume of a cuboid, which is a prism. Remember, guys, the volume of any prism is equal to the cross-sectional area. That means if I slice the shape from front to back, the shape I continue to get is my cross-section. So if I know the cross-sectional area multiplied by my length, or we could say our height. So in this question, we are already given the area, which is the area of the cross-section. Therefore, I need to find the length of it, or we could say the height. So I need this side L here. Now, I can see I have this triangle, which may help if you draw it out like this. I know the angle here is 26. I know the hypotenuse is 18, but I need this length here to complete the set. So what I'm going to do, I am going to look at my trigonometric ratios, which one is best to use. So if you look here, label from here, I've got the opposite side. So this is my opposite, and I've got my hypotenuse. So again, I'm using sine. Just normal trig values now, so CAH TOA. So sine 26 is equal to the opposite side, which is L, divided by 18. So I am going to put this over 1. 1 times L is L, and then I need to do sine 26, put that in bracket, times by 18. So let's go. Sine 26 multiplied by 18, and that gets me 7.89. Again, I'm putting that on my diagram, close my gaps. Okay, now I have enough information to find the volume, because remember, I have been given the cross-section, which is the base area. So the volume then is equal to my cross-sectional area, which is 6160 centimeters squared, multiplied by my length now, which is 7.89, which I just found, centimeters. So put that in my calculator. I already have the 7.89 left in my calculator. So now I just need to times by 160. I get 1262.5 centimeters squared times centimeter gives me centimeters cube, which is the unit for volume. Fantastic. Guys, comment section need to be active at this point. We need to be talking back as to how are we feeling? Are your anxieties reducing? Are you understanding the concept? Come on, let's go, team. Let's go. You've got to talk back to me. Okay, now I have this final question I'm going to do with Pythagoras in 3D. The diagram shows a pyramid this time. The base of the pyramid is ABCD is a square. Very important information. We are told that AB is equal to 6. I'm putting that straight away, 6 centimeters. And the point P is 12 centimeters vertically from the base. So from P vertically to the base, I'm putting in that line, that's 12. Very important information. Okay, it says calculate the size of angle PAC. So I need this here. Beautiful. Now I've got to be thinking. If it is a square for the base and AB is 6, it reasons that all the sides are also 6. So A to D is 6 as well, and D to C is 6 as well. Now, if I'm going to find this angle here, I need to know A to the center as well. I have enough information using the base. So if I find all the way across, so I'm just going to make this a little bit tidier, all the way across, I can see this is a right angle triangle here. So I need to find the length AC, and then I will need just a half of AC to get the base of this triangle here. So again, I'm going to use Pythagoras' theorem. So let's call this AC. So AC squared will be equal to 6 squared plus 6 squared. Therefore, AC would be equal to the square root of 6 squared plus 6 squared. We put that in our calculator, 5 marker. Use your calculator to your advantage. So we know this is the square root of 36 plus 36. We can just put that all in at the same time. That is equal to 72. So square root of 72, which is essentially 8.49. So all of A to C is 8.49. However, I need halfway just to here. So I now need to do 8.49 divided by 2. Got that in my calculator as well. So I just need to do divided by 2. And that is 4.24 to 2 dps. So I know this is 4.24. Now, guys, I have enough information now. Since I know this is 12 long and I know this is 4.24, then I can focus on this two-dimensional shape. I need the angle here, and I know this is 12, and I know this is 4.24. Beautiful. So again, I go back to my trigonometric ratios. So the angle I want is facing 12, which is the opposite side, and this is the adjacent. I am using OA, which is the tan ratio. So tan of the angle, so I'm just going to say tan A is equal to the opposite side, which is 12, divided by the adjacent, which is 4.24. I know I will have to do inverse function. Once at all, I'm finding an angle. So we can go straight ahead to do either work this out or just put it all in our calculator at the same time. So I'm going to do A equal to tan inverse of 12 over 4.24. Put that all in my calculator at the same time. I get, so shift tan, so 12 divided by 4.24, that gets me 70.5 to 1 decimal place. And remember, it's an angle, so that is in degrees, guys. Speak the truth. Isn't that a beautiful 5 marker once we know how to break things along? It is indeed a good 5 marker there. Absolutely fantastic. So now we are going to be going on to looking at histograms. I know that's a topic that most people don't like at all. But guys, if you don't see histogram on paper 2, you will more likely see it on paper 3. And you know what? Over the last few years, histograms have not come up. So could this be the year that you will find the histogram questions? And if you do, I'm sure you will be ready. Beautiful. So in this question, we're told that the table shows information about the height of 40 plants. Key point there, so 40 plants. The table shows information about the height of 40 plants. We are asked to draw a histogram to represent the heights for 4 marks. Now, guys, the first thing we need to know about histograms is that we have to find our frequency density to plot our points, or to draw the graph rather. So if we look here, we have frequency, we have class width. So the missing one here is our frequency density. We need to also know the triangle for this. So just drawing the triangle here, any one of the values we're given, we should be able to find the other ones. Frequency goes at the top of our triangle. Then we've got our class width and our frequency density. So frequency is equal to the class width multiplied by the frequency density. Now, if we want to find the frequency from the histogram, we are essentially finding the area of the bar. We are going to elaborate on this as we go further. So to find the frequency density, we need to do the frequency divided by the class width. So frequency divided by class width give us frequency density. So on the diagram, we are given the frequencies already. We need to work out the class width. So from 0 to 5 is 5 for the first class width. From 5 to 15, that's 10. From 15 to 25, that's also 10. And from 50 to 25, 25 to 50, that is 25. Beautiful. So we wrote our class width. Now, guys, they don't have to give you the table with the unfinished work. They could just give you the height and the frequency. You've got to know that you need the class width and the frequency density, okay? So frequency density is our frequency divided by the class width. So I need to do 6 divided by 5. So 6 divided by 5. So put that in our calculator. 6 divided by 5 gets us 1.5 for the first density. Next, we need to do 15 divided by 10. Nice and easy one. That is equal to 1.5. Then 9 divided by 10 as well. Easy one, 0.9. And then we are doing 10 divided by 25. That is 0.4. Make sure you put that in your calculator. What you don't want is to make the mistake of doing 25 divided by 10. Wrong. So 0.4. Now we've got our frequency densities. We are going to be drawing our histogram. So the first one is from, so the width of it is 5. So we need to go 0 to 5. But let's get our scale in first of all. I think I have pre-put my scale in. I'm using 1 for every 2 large spaces. So there we go. So the first one is 0.5, which means that this is 1 here, and so on. Now I need to draw 5 width, and the frequency density is 1.2. That's why I put 1.2 here. So my bar is going to go here. I pre-draw it in to make it neat as well. From 0 to 5 need to go to 1.2. So that's the first one. The second one, we are going from 5 to 1.5. So 5 across, it's supposed to be 10 wide. So 10 wide, and then we need to go up to 1.5. So 10 wide, 1.5. There we go. I've used different colors to make you see it clearly. For the next one, we are going from 15 to 25, which is 10 wide again. So 10 spaces wide, and then that goes up to 0.5, which is just 1 below the 1 bar there. Then we need to do width for the next one is 25 wide and up to 0.4. So 25 wide, 5, so 10, 25, and then we are going up to 0.4. And there we have it, guys. Once you completed your table, you put in your frequency density, and you've drawn this accurately, you would have scored that 4 marks. Nice and easy. Remember, histogram, no spaces in between. Bar charts, however, have spaces in between. Beautiful. So histograms aren't testing drawings, guys. They are testing whether you understand your density. There is where the marks are. Now, remember, if a histogram is given to you and asked to criticize it, one of the main critiques is always the fact that they've put frequency instead of frequency density. This has to be frequency density. And when you're drawing the graph, make sure you put frequency density. If you put frequency, you lose the mark for that. So look for that. Also, some of the other critics is that they may have calculated the frequency density wrong, or the bars may be too wide or too high. So make sure you check each one and see if it's accurately drawn. Beautiful. Okay, next question now on histograms. We are told that 62 students recorded how many hours they spent revising for a test. That's you guys, you have been revising a lot. The histogram represents the result. Work out an estimate for the mean time of the 61 students spent revising. You may use the table to help you. Beautiful. So, a very good opportunity to see how to calculate the frequency if we are given the histogram. So most of you know how to calculate mean. We're going to revise that as well. We are expecting to see that question come up, whether for the histogram one or just calculating and estimating the mean. So we need to get, first of all, our frequency. That wasn't given, but we can get it by finding. So frequency from the histogram is the area of each bar. So basically, remember we did our triangle where we said frequency at the top. Frequency is equal to the class width multiplied by the frequency density. So we're given the densities here, and we know the width of the bar. So by finding the area, we can multiply the width, class width, times the density to get the area of each bar. So I can see that this is 1.5 away here, and then 2, 4, 6. So essentially for this one, we are doing 6 times by 1.5, not taking any chances, putting things in my calculator. So 6 times by 1.5. The frequency here is 9. We put that in on the diagram. For the next one, this goes up to 3.5. So this is 3.5 here. So we are doing 3.5, and then we've got 2, 4. So we're doing 4 times by 3.5 for this one. So 4 times 3.5, that gets me 14. So 14, I'm putting that on here. Next one goes up to 5, and I have 2, so that's just 5 times by 2, which is 10. We put that in. Next, we have 2, 4, and this goes up to 4.5. So 4 times by 4.5, 4 times by 4.5, that gets me 18. So this one is 18. Next, I have 2, 4, and that's 4 times by the height of this one here is 2.5. So 2.5 times by 4, that is 10. So we go here. Beautiful. So the next thing we need to do is the midpoint of the intervals. So 6, half of 6 is 3. Then we've got halfway between 10 and 6. So add them together. 6 plus 10 is 16 divided by 2. That's 8. Then I've got 10 plus 12. That is 22. Half that is 11. Then 12 plus 16, 28. Half of that is 14. And then I've got 36 between these two. So 20 plus 16, 36. Half of that is 18. Now I've got all of that. Remember, I need to find fx. So we need to multiply these across. Remember, calculator paper, guys, even simple timetable, use your calculator. 9 times 3, that's 27. 14 times by 8, that's 112. This one is simple, so 10 times 11, that's just 110. And then I need to do 18 times by 14, that is 252. And then I need to do, this one is also simple, so that's just 180. So we are adding this, remember, the mean is equal to fx, the total of fx, divided by the frequency. So we know that it's 61 people. So we know this column adds to 61. You could just check it to make sure. And then we need to add this. So 180 plus 252 plus 110 plus 112 plus 27. That gets me 681, and I'm dividing that by 61. So that is 11.16 or 11.2 to 1 decimal place. And that's how we find an estimate for the mean from a histogram. Absolutely brilliant, guys. I'm so proud of you for investing in your independent studies. Beautiful. So another question on histograms. This time, we are told that 48 students completed some homework. The histogram shows information about the times taken. We're asked to work out an estimate now for the interquartile range, and you must show your working. So for some of these, I forgot to put the marks in, but there are 4 and 5 markers. So interquartile range from the histogram, yes, that's a question that may come up as well. We know that interquartile range is equal to our upper quartile take away our lower quartile. So we need to find what our lower quartile and upper quartile is and then subtract them. So first step is to find our lower quartile. So the lower quartile is equal to the total student, which is 48, divided by 4. So 48 divided by 4, make sure you don't play around with this, use the calculator. That's equal to 12. Remember, this is the 12th value. So it's not 12 that's the lower quartile, it's the 12th value. So we need to find out which one of these bars we will find the 12th value in. So that means we need to work out the frequency for each of these and see where we are. So I can see here we've got 5 across and this goes up to 1.6. So we need to do 5 times by 1.6. So 5 times 1.6, that gets me 8. So this bar is worth 8, but I need to go up to 12. So let's work out this one and see how much out of this one we will need to make 12. So this is 5, 10, and we are going up to 0.8. So I need to do 10 times by 0.8. So 10 times 0.8, that's just 8. So this is all of 8, but I've got 8 already for the first bar. So to get up to the 12th value, I need halfway of this one. So halfway is here. which will be the lower quartile then is 10. So LQ is equal to 10. It is the 12th value. So 8 plus halfway, which is 4. 8 plus halfway, which is 4, will give me my 12. So that's 4 here, and this part is 4 as well. Okay, so this 8 plus this 4 gets me to my 12th value, which is actually on 10. Beautiful. So we have the lower quartile. Now I need the upper quartile. So we know the upper quartile is 3/4 of the data. So it's going to be my lower quartile times by 3. So this is a quarter, 3/4 will be. So I need the 36th value. So far we have 8 here and 8 here. That's 16 with these 2 bars. I need to get up to 36th value. So I have to keep going. So I'm going to now find the area of this bar. So this is 510 multiplied by 1.2. So 10 times by 1.2, that is 12. So this is worth 12. Let's see how much we have so far. So I've got this 12 here, plus 8, which is 20, plus this 8, which is 28. So 36, take away the 28 we already have. 36 minus 28, so I need 8 more out of this one. So I'm going to need 8 out of this one. So let's calculate it and then find where 8 is. So I've got 5, 10, 15, 20, and this goes up to 1. So 20 times by 1 is 20. So all of this is worth 20. I just need 8 out of that 20. So let's find 8 out of this 20. So this is 5, 6, 7, 8. So I just need to go down. Use your ruler to do it, guys. So if this is 30, which is half, this is 5. From here is 5. So 3 will get me to 33. So my lower quartile, upper quartile then is the 33. So the interquartile range is equal to 33 take away 10, which is equal to 23. Check that off. And that's how I find the interquartile range from the histogram. So remember, lower quartile, divide my data value by 4, it's the 12th value. This bar is 8, I need 4 more, so I have to get 4 from this one. So when I work out this bar, it's 8 as well. I need half of that brings me to 10. The lower quartile is 10. I need the upper quartile now, so it's the upper quartile will be the lower quartile times by 3, because 12 is a quarter, I need 3/4, so I times it by 3. It's the 36th value. So the 36th value, I know this was 8, this is 8, and this is 12. So 12 and 8 was 20. 20 plus 8 is 28. So from the 36 I need to go up to, I already have 28. So I need 8 more out of the last box here. The last box is 20 times by 1. So I need 8 out of the 20. From 25 to here is 5. 3 more will get me to 33 for the 8. So the upper quartile is 33. And then I subtract them. Absolutely fantastic. Guys, if you get this question, you'll be so happy because I know you know how to do it now. Absolutely fantastic. Last thing that we're going to do on histograms now that they could ask you for is to work out the median. So this question is on the median this time. So the histogram shows information about the masses of some apples growing in a garden. We are asked to work out an estimate for the median mass of the apples. So we know median is halfway. I love to sing this to my classes sometimes. The median is the one in the middle. We add and divide for the mean. The mode is the one that occur the most, and the range is the difference between. Guys, people who get that mixed up all the time, once you know that little jingle there, you'll never forget it again. So we know that the median is halfway of the total. The value halfway. So median is the middle value. But we have to first of all know the frequency to half that to see what is the halfway value that we are working with. So again, we need to work out all the frequencies to see how much is the total that we have here. Remember, to work out frequency, it's the class width multiplied by the density. So we have here 10, 20, 30. So this goes up to 30, 30 times by 2. So the first bar, we can just label that bar 1, bar 2, bar 3, and bar 4. So the frequency 1 would be equal to 30 times by 2, which is 60. I'm going to put that on my bar, so that is 60 here. For the next one, 10, 20, 30, 40, 50, 60 as well. 60 times by 2.5, so this is 2.5. So frequency 2 is equal to 60 times by 2.5. Use my calculator for that. So 60 times by 2.5, that gets me 150. So I need to find frequency 3 now. So 150 here. Frequency 3 is just 10 across by 5. So 10 times by 5 is equal to 50. I'm putting that on here. So this one is 50. And then for the last one, 10, 20, 30, 40. And that is being times by 1. So that's just 1 times 4e, which is 4e. So put that on the bar. So now, to get the total, we just need to add this up to see. So we need to do 60 plus 150 plus 50 plus 40. Okay, so adding those together. So adding them all up, 60 plus 150 plus 50 plus 40, that is equal to 300. So the median now would be 300 divided by 2. So half 300, that's just 150. So it's the 150th value that we will find the median. So this is 60 here. Let's see how much we need to get up to 150th value. So this is 60. So we need some out of this one. So we know the median will be here. So 150 take away 60. See how much more we need? That is equal to 90. Okay, so it is the median is here in this second class. So the formula for finding the median now is this. We need the lower bound of the class that it's in. We know it's this one. The second one is the lower bound, plus it's going to be the position that it's in out of the total and multiplied by the class width. So let's do it now. This one, the lower bound is 30. So we substitute that in, plus the position that it will be. Remember, we subtracted that. So it's the 90th position there. So the position in the class that we need to get up to is 90 out of the total that is in the class is, so class width 10, 20, 30, 40, 50, 60. So that's, no, let's do it again. So it's 150, guys, sorry. It's out of 150, this one here. So multiplied by the class width, which is 10, 20, 30, 40, 50, 60. All right, so we're going to put all of that in our calculator now, then we'll get our value. So I was mixing up my class width a while ago with my total. So 30 is the lower bound of the class that it's in. I know it's in the second class. I need the lower bound. And how much more out of this one I need? I've got 60 here. I need 90 out of this one. So it's 90 out of the total of 150. So 90 out of the 150. And then I multiply that by the class width. And the class is 60 wide. So from here to here is 60 wide. Now, once I put all of that in my calculator, I have now found my median. So let's do that. So 30 plus, I'm going to use my fraction button here, 90 out of 150. And then I need to multiply that by the class width, which is 60. And the answer is 66. So that's my median. Make sure you know these bits, because if you don't see it on paper 2, more than likely you may get an histogram, unless they're very kind this year as well and not bring the histogram up. But as I said before, I am expecting an histogram this year. Okay, beautiful. So now we go to distance time graph. So Brian visits a library. He cycles to the library at a speed of 18 miles per hour. So 18 miles equal to 60 minutes, 18 miles per hour. He stays at the library for a period of time. We can see the rest here. He then cycles home. So from here all the way home. The sketch graph represents his visit. The sketch graph, that statement just sounds weird, isn't it? The sketch graph represents his visit. So we got his distance here and we got his time of the day. We are asked to work out the speed in miles per hour. That's important, per hour, at which he cycles home. So remember, his distance that he traveled first was 18. So this is 18 here. And he did that in miles per hour. So if he's traveling 18 in 60 minutes, then therefore we can get what it is in terms of an half an hour. So if I do 18 divided by 2, I can recognize that that's going to be equal to 9 miles. So he will have traveled. So here, this is where he is. That's where the half an hour is coming from. That's why I need to find halfway. So in half an hour, he would have traveled 9 miles. Okay, now we know that he's going to take the same miles, the same time to get back home. So it's going to be the same distance, 9 miles. However, we need to check the time here. So speed is equal to distance divided by the time. So it's the distance is 9 miles he's going to take. And that's because we knew that he traveled here in half an hour. So it's going to be 9 miles, but from 10:30 to 11:15. 10:30 to 11:15 is 45 minutes. But guys, we need to give our time in miles per hour. So we need to convert this 45 minutes into hour. So we need to divide that by 60. So 45 divided by 60 to get that into hour is 3/4 of an hour, so 0.75. So now we need to plug that into this formula. The speed will be equal to the distance, which is 9 miles, divided by 0.75. So 9 divided by 0.75, and that's equal to 12 miles per hour. So guys, we need to make sure that we're looking at the units that we're given and how the question asks us to represent the answer. Okay, once we've done that, we're supposed to be okay for this nice 3 marker here. Beautiful. Okay, so we're going to do one more question on distance time graph. But my question is, have you liked the video yet, guys? And how is the revision going for you? I feel excited that you are being prepared, and I am happy for you. I know when you get into that exam, you're just going to be calm. You know you're well prepared, and so it's game on. It's execution time. And once you're able to stay calm, guys, there's no question that you can't break through on. Brilliant. So now, guys, let's have a look at this question. So here is a sketch of a speed time graph for a part of a journey. We look at the graph, we see speed is our frequency, and we got our time on our x-axis. The average speed from 0 to t was 12 meters per second. Work out the value of t. Beautiful. 5 marks, guys. So we know speed is equal to distance divided by the time. So from the graph, in order to find the distance, it is the area under the graph. So we need to find the area under the graph to get the distance. So that's what our distance is from these graphs. And we know what the speed is equal to. So we'll make an equation after finding the distance and then solve it for t. So we're going to split this up in shape 1 for the triangle, shape 2 for this rectangle, and shape 3 for this trapezium. We're going to find area 1 first of all. So area 1 is equal to, we know area of triangle is base times the height divided by 2. So for this, the base is 18. So arrow, no 2 equal signs in any equation there, no. So arrow, 18 multiplied by the height of the triangle here is 16. You can see that it goes up to 16 here. And then we need to half that. So I'm just going to put that in my calculator. So a half times by 18 times by 16. That gets me 144. So next we're going to do, so that was area 1. Now we're going to do area 2. So area 2 is the area of a rectangle. So 18 to 32. So we need to subtract that. So 32 take away 18. That gets us 14. So this is 14 here. And then the height of it is also 16. So for that, we're just doing 14 multiplied by 16. Brilliant. So the area, 14 times by 16, that is 224. Need to wear my reading glasses more, guys. So it's 224. All right, now, so we're going to write area 3. So area 3 is our trapezium. So we write the formula for that. So the area of a trapezium is half A plus B times by the height. Remember, A and B are the parallel sides. So A and B are these two. So we can see that this goes up to 12. This section goes up to 12. And this section goes up to 16. So A and B are 12 and 16. And our height now would be from 32 to T here. Okay, so let's substitute and we're going to put that in. So basically, if we should get the distance, just like we did 32 take away 18 to get 14, to express the height here, it will be T take away 32 for the height. Okay, so now we're going to substitute that in. So it's half. A is 12 and B is 16, and we're going to multiply that by the height, which is T minus 32. So let's work this bit out. So 12 plus 16, that's 28, and half of 28 is 14. So we are essentially, all of this works out to 14. We need to multiply that by T minus 32. So 14 times T is 14T. And 14 times by minus 32. So 14 times by minus 32 is minus 448. So now that we have all of the bits, we need to add them together for the distance. So the total distance is equal to, we got 144 there, tick that off, plus 224, tick that off, plus what we just got here, which is 14T minus 448. So let's simplify this now. Put this all in our calculator. So 144 plus 224, and then we are subtracting 448. So that gets us to minus 80. So we will have 14T and then minus 80. So that is the total distance. So now we're going to substitute back in our formula that we written down before. So the speed is equal to our distance, which is 14T minus 80 divided by our time. And we don't know what the time is. It's a T seconds, so divided by T. Okay, guys, one good thing is that we know the speed already. So it's just going to be substituting the speed for 12 is equal to 14T minus 80, which is our distance, divided by our time, which is what we were given to be T seconds. So now we just need to solve this to work out the value of T. So 12 times T, cross multiply here, will give us 12T is equal to 14T minus 80. So now we need to just solve this. So we can put the 80 here, swap sides. So positive 80 is equal to 14T take away 12T. So 14T take away 12T is 2T. So if 2T is worth 80, let me just continue here. 2T is equal to 80. Dividing by 2, I get that T is equal to 40. Well done. So T is 40. And again, we can plug that in if we have time, making sure that we check them now that we know what T is and make sure that it checks out to be 12 when we do the distance divided by the time. 5 marks, guys. 5 marks. So once we're asked to find distance from a graph, it's the area under the graph. Beautiful. So now we carry on with functions. We know this is coming, guys. We know we are going to have some functions. So we're told that f of x is equal to 3 to the power of x and g of x is equal to 3x plus 7. We're asked to work out the value of f of 2 plus g of 5. This is simple substitution. So we are substituting. So f of 2 would be equal to, where x is in f, we are putting 2 there, so that's 3 squared. Beautiful. And that gives us 9. So for the next one, where we are substituting for g of 5, in this one, we have 3x plus 7. So where x is, we're replacing it with 5. So 3 times by 5 plus 7. So 3 times 5 is 15. And 15 plus 7, that is 22. So let's do it now. So f of 2 plus g of 5 then. F of 2 we got 9. G of 5 we got 22. So 22 plus 9, that's 31. Do you see, guys? I'm not taking chances for simple things. I'm using my calculator. Make sure you do that. Okay, so we finished with that. Let's go to part B. So part B asks us to work out the value of g of f of 2. Remember, this means that we are putting 2 into f and then putting that answer into g. So let's do f of 2 first. So f of 2 is equal to 3 to the power of 2, because remember, where x is, we are putting 2 there. So f of 2 is 9. 3 squared, 9. We're going to now put this 9 into g. So that will be 3x plus 7, but I'm putting the 9 for x that I just got from here, and then add 7. So 3 times 9, that's 27 plus 7. That's equal to 34 altogether. Beautiful. Now, part C says, determine the value for x for which g of x is equal to g inverse of x. So we know g of x is equal to 3x plus 7. We need to make it equal to the inverse. So the first thing here is to find the inverse of g. So to find g inverse, remember, when we are finding the inverse of a function, we first set the function to y equal to. So instead of g of x, we are going to write y equal to 3x plus 7. I now need to rearrange to make x the subject. So to find the inverse of a function, I set the function first of all to y equal to. Then I'm going to find the inverse by rearranging to make x the subject and then interchange x for y. So here I have to subtract 7 from both sides. So y minus 7 is equal to 3x. I now need to divide by 3. So therefore, x then is equal to y minus 7 thirds. But I need to now do g of inverse of x is we're going to interchange this x for what they've asked us to do, and then this y, we replace it back with the x that we had. Now let's look. We were multiplying by 3. We're now dividing by 3. We were adding 7. We're now subtracting 7. We're doing the inverse. Now that we know what this is, they've told us to solve g of x, which is 3x plus 7, and to make that equal to the inverse, which is x minus 7 thirds. So we're going to solve this now. We know that we need to multiply by 3. So 3 bracket 3x plus 7. So that's that 3 we've brought there as a multiplication is equal to x minus 7. So 3 times 3x is 9x. And 3 times by 7 is 21. Again, use your calculator, guys, to get this value. And then that's equal to x minus 7. Collecting like terms, I'm going to subtract x here. So 9 minus x, 9x minus x equal to minus 7. I'm going to put this positive here. So that's going to be minus 21. So 8x, when we subtract those, is equal to minus 7 minus 21, calculator paper, that gives us minus 28. Beautiful. So last step now is to divide by 8 on both sides. So x is equal to negative 28 eighths. We could simplify that further by just putting that in our calculator. So x then is equal to, let me see, negative 28 divided by 8. That gets me negative 3.5. So we can end nicely to say g of x equal to, the inverse here is equal to negative 3.5. Brilliant. See? Lots of different things coming together. Of course, you will recognize that through all our topics, algebra remains the champion because it's in everything, guys. That's why we want your algebraic skills to be strong, because if it is, you'll be able to apply appropriately. Next, we go for finding the inverse. You can pause the video at this point, guys, and work the inverse out since we've done it before. So to find the inverse of, we're given that f of x is 5 over x plus 10, and g of x is the square root of x cubed, 2x cubed minus 3. We're asked to work out the inverse of f. So set the function f to y equal to 5 over x at 10. And so therefore, I need to multiply by y first. Remember, I want to make x the subject here. So I need to do y bracket x plus 10 equal to 5. Remember, x is my aim. At the moment, I'm multiplying by y. I now need to divide both sides by y. So y cancels out, leaving me with x add 10 equal to 5 over y. Now I need to subtract 10 from both sides. So x then will be equal to 5 over y minus 10. Remember, I changed the x here for my inverse I was given. So f inverse of x then is equal to 5. Remember, changing back my y for x minus 10. And that's my final answer. Beautiful. Now we go for the next one, making the inverse of g. So set the function to y equal to, we have the square root of 2x cubed minus 3. Guys, we know that we're making x the subject here, but we don't have access to x. We need to remove the square root with a square. So we're going to square both sides. That's equal to the square root of 2x cubed minus 3. We're squaring both sides. Squaring removes the square root, so y squared is equal to 2x cubed minus 3. Now we need to do the inverse of minus 3, which is plus 3 to both sides. So y squared plus 3 is equal to 2x cubed. Now I need to divide by 2. I need to get x on its own. So dividing by 2, we will now have y squared plus 3 halves is equal to x cubed. Final step to get x on its own, we're doing the cube root of both sides. So this simplifies the x. So x is equal to the cube root of y squared plus 3 over 2. Now I need to rearrange this back into g inverse of x. And then that's equal to the cube root. Instead of y, we put back our x now. So x squared plus 3 all over 2. Make sure we know that this root here extends. Okay, let me just fix that up nicely. So erase that bit and make it nice and neat. You got to show that everything is within the root. Okay, so that is our answer there. Okay, next question. We are given that f of x is 2 to the power of x, g of x is 1 minus x, and h of x is equal to 2 plus x. So here we are asked to show that f of h of x divided by f of g of x is equal to 2ax plus b, where a and b are integers. Beautiful, for 3 marks. So first thing, this means I need to put h into f. So let's write f of x first. So f of x is equal to 2 to the power of x. So to do f of h of x means that where this x is, I am now going to replace it with what h is. And h was 2 plus x. So I'm replacing it with all of this. Okay, so where the x is in f, I need to replace it with the value of h of x. So I've done that. Now I need to do the same for the denominator and then put them back as a fraction. So I'm going to write f of x again, and that is 2 to the power of x. So to do f of g of x, I'm going to replace the x here with what g is, which is 1 minus x. There we have it. So now we're going to put it back as a fraction and simplify to get this form. So 2 to the power of 2 plus x was what I got for the numerator, divided by 2 to the power of 1 minus x. That's what I got for the denominator. Now, this is the laws of indices. So remember, when the base is the same, we should subtract the powers. So it's 2, and then I have 2 plus x minus, put in bracket what I'm subtracting. I'm subtracting the other power, which is 1 minus x. Now I need to expand the bracket. So it's 2 plus x minus times by 1 is minus 1. And negative here times negative will give me positive x. Collect my like terms now. I have 2 take away 1, which is 1. And then x plus x is 2x. So guys, I'm going to rewrite it in the form with the x first. So 2 to the power of 2x plus 1. And now I've written it in that form. I can also qualify this by saying a therefore is 2, because it's the coefficient of x here, and b is 1. Absolutely fantastic. So it is just application. And if you can apply knowledge, guys, you will be unstoppable. Beautiful. So moving along to another question here. So I am going to be looking at, I'm going to skip these two questions. I'm going to skip these two questions because we've done enough on inverse of functions. So we are given this graph here. We are told that one of these graphs is a sketch of y equal 3 to the power of x. Which one? We are asked to circle the correct one. So guys, the first thing that we can do here is to select some coordinates for x and see, what are the possible y values. So I'm going to choose work out y when x is 0. So if x is equal to 0, it will be 3 to the power of 0. So when x is 0, then y is 3 to the power of 0 is 1. So I'm looking at coordinate 0, 1. Remember, it's a sketch, so I'm just going to estimate it. So what about when x is equal to 1? When x is equal to 1, then it would be y equal to 3 to the power of 1, which means y is 3. So coordinate 1, 3 would be another one. What about when x is 2? If x is 2, then y would be equal to 3 to the power of 2. Y would be equal to 9. So another coordinate is 1, 9. So let's check. First coordinate we didn't have anything that went below here. Not passing through 0, 0. Couldn't be that one at all. This one is a negative one, so can't be that one. And here we also have 0, 1. That's okay, but we didn't have any negative coordinates here. So if we check here, 0 to 1 could be here. This graph is increasing 1, 3, and so on. So we reason that C then is the answer. They said circle it, so I would put a circle there. Beautiful. Now let's go for transformation graphs now. So the graph of y equal f of x and y equal g of x are shown on the grids below. We are asked to draw the graph of y equal negative f of x onto the first grid. So guys, when we have negative f of x, this is basically just a reflection in the x-axis. So we get the major points here. So from here, 1, 2 down, we need to have 1, 2 up for the next one. So we know 1 point is going to be there. So if we look at this one, we have 1, 2, 3, 4 up is going to be 1, 2, 3, 4 down. So basically, once we get key points, This is another key point we could do. We got 1, 2, 3 down, 1, 2, 3 up. So we are drawing basically identical to what we have. Now to make it nice and neat, I have just pre-done that for you. So basically, key points, you can see that I've done here. You are just drawing it the opposite way now and making a reflection of that through the x-axis. So that's because there is a negative on the outside here. So reflection in the x-axis. Now, if you notice, for g of x for part B, this is now inside the bracket. So that means we are reflecting in the y-axis. Same principle apply. From here, key point 1 away. On the other side will also be 1 away. And then I've got this bit, 1, 2, 3, 4. On the other side, 1, 2, 3, 4 is where I'll find that coordinate as well, and so on. So once we do that, we just need to establish our lines and stuff. This one was here. And then we are making the corresponding graph, which I have pre-done as well. So look at that, key point, key point. Get all your key points and then join them up. So the key thing here is to know the difference in a reflection in the x-axis versus a reflection in the y-axis. We get that? Those two marks are within our grasp. Now we've got this question here. The graph of y equal 10 minus 2x squared is translated 3 units to the right and 1 unit up. The translated graph as equation y equal f of x. Work out f of x and give your answer in the form ax squared plus bx plus c, where a, b, and c are integers for 4 marks. Now guys, we need to focus on the fact that, so we're going to have y equal to f bracket x. Let's see what goes on here. So we have translated 3 units to the right. Remember, when we go to the right, it's the opposite of what we expect. We are going to have a negative coordinate there. And we have 1 unit up, so plus 1. But remember, if you look here, this is a square here. So what we're going to need to do is to square this bit here. So we are going to be substituting into the original that we have been given to find the answer. So then we need to write 10. So I'm going to put this back. 10 minus 2x squared. So remember, if you go to the right, guys, it's a minus that you're going to have in bracket. If you go to the left, it's going to be a positive. It's the opposite of what you expect it to be. So now we're going to substitute this into this one. So it's going to be, notice I wrote this back first so I can see my substitution. So it's going to be 10 minus 2 bracket. For x now, it would be x minus 3, which is being squared. And then I've got a plus 1. Beautiful. So this is double bracket. So I'm going to have 10 minus 2. Let's work out the bracket first. We need 2 of these brackets since it's being squared. And then don't forget your plus 1. So 10 minus 2, I'm going to do x times x, which is x squared, and x times by minus 3, that's minus 3x, and then minus 3 times x, also minus 3x, negative times negative 3 here is positive 9 plus 1. But we need to start this bit out by expanding the bracket. So 10, minus 2 times by x is minus 2x squared. Negative times negative here, I'm just going to do these two together, which is minus 6x. And then do negative 2 times minus 6x is positive 12x. And then minus 2 times by positive 9 is minus 18. And then I had the plus 1. Now I can simplify everything. So I've got minus 2x squared and then positive 12x. I now need to just simplify the numbers. So 10 plus 1 is 11, and 11 take away 18 is equal to minus 7. Okay, so my answer then, y then will be equal to minus 2x squared plus 12x minus 7. And that's my answer for 4 marks. So you'll find these to the back of the paper. Most people just walk away and leave these. No, guys, once we learn how to think, so if we're going to the right, 3 units to the right, we represent that as minus 3. If it was to the left, then it would be positive. It's the opposite of what you expect it to be. Absolutely fantastic. And make sure you follow the order of operations. Okay? All right, so we're going to do this other question, and then we are going to do some other graph work. Okay? So I am told here that here are the sketches of 2 graphs. Graph A has equation y equal x squared plus 4x. Graph A is translated to give graph B. See that? So that the turning points are minus 2, 4. Okay? Now, I'm told that on the graph A is mapped to B with the points 5 to minus 1. So that's that on graph B. Work out an equation for graph B and give your answer in the form x squared plus ax plus b, where a and b are integers for 4 marks. So the first thing we need to do is to find out how did we get from here to here. So from this point to that point. So if we subtract the x coordinates and the y coordinates, we'll see the movement that we have made. So x coordinates, 5, take away x coordinates here, minus 2. 2 negatives give us a positive. This is 7. So if this is a positive 7, that means we need to have a minus, because this means that we went right. So basically we have to think about the left movement. So left, and we did that in the one before. For the y coordinates now, I've got minus 1 minus 2. This is now a plus. So this is minus 1 plus 2, which is positive 1. So this means, this is minus 1 minus 4. So this would be plus 4, so that's positive 3. So that means 3 up for y. Beautiful. So now that I've got that, I'm just going to put it in to this that I've got here. So this means, first of all, let's put what f of x is. So this would be f of x. This is now going to be to the left because it was to the right. I have to represent it with a negative, okay? So positive is going to be a minus. And so then we know that we need to go 3 up. So we're going to substitute this now. This is our movement into what we were given here. So therefore, I will have x squared plus 4x. So I'm substituting this in for x. So it's going to be x minus 7, that is being squared, plus 4 bracket for x again, x minus 7, and at the end we should plus 3. So we need to expand our bracket. So we're going to be expanding our bracket, guys. So we're going to do 2 of this bracket here. So x minus 7. So x times x is x squared. X times by minus 7, minus 7x. Minus 7 times x, minus 7x. And negative times negative, positive 49. Plus 4 times x is 4x, and 4 times minus 7, minus 28, plus the 3 at the end. So now we need to simplify. We got x squared here. Minus 7 minus 7x is minus 14x. And then I have this plus 4 here, so plus 4x. And then I've got 49. I'm just going to put this in my calculator. So 49 plus the 3, minus 28, and that gives me minus 24. Simplify the middle a little bit. Minus 14 plus 4 is minus 10x minus 24. So they've asked us to give it in the form ax squared plus bx plus b. So I've got x squared minus 10x and minus 24. You may need to watch this question over again just to make sure that you got this one. Absolutely fantastic. So now we're going to look at error intervals. Yes, we know this one always comes up, guys. So the length of a wall is 9 meters to the nearest meter. That's important. So 9 meters to the nearest meter. Complete the error interval for the length of the wall. So if it's to the nearest meter, we know that we had a decimal that rounded to the nearest whole number. So that means to 9, we are adding and subtracting 0.5. So 9 take away 0.5 gets us our lower bound, and 9 plus 0.5 gets us our upper bound. So we know lower bound 8.5 and upper bound 9.5. Remember, this is 9.5 would not be included. This less than here means everything below 9.5. Tick that off. We go to the next question. When rounded to one decimal place, k is equal to 3.1. We are asked to complete the error interval for k. So again, because this is to the nearest decimal place, something was here that rounded to give us 3.1. So we are adding and subtracting 0.05 this time. So lower bound, skipping too fast, lower bound would be equal to 3.1 take away 0.05, and upper bound is 3.1 plus 0.05. Easy way to do this, just put our 5 here, and that would be the upper bound, and reduce this one by 1, or you could just put that in your calculator. So 3.15 and 3.05, because this now for the lower bound would be reduced by 1. So put it in your calculator, get the actual values there. Beautiful. The key point is to know what we're adding and subtracting. So when rounded to 2 decimal places, t is equal to 8.52. Complete the error interval. So again, 8.52. Something was here then that rounded to 2 decimal places. So 0.005 is what we are adding and subtracting. So 8.52 plus 0.05 and 8.52, subtract 0.05. Put that in our calculator. So 8.52 plus 0.05, that gets us 8.525. You can see for the upper bound ones, guys, if we put a 5 here, we just need to reduce this one by 1 for the lower bound. So to subtract that, let's change the plus here to a minus. I get 8.515. Beautiful. See, not hard at all. When rounded to the nearest 100, W is equal to 41,600. So we know, again, this is halfway of 100. So 100 divided by 2 is 50. So to get the upper bound, we are adding 50 to this. And so upper bound would be equal to 41,600 plus 50. And the lower bound is 41,600 take away 50. Beautiful. So the lower bound then is 416550, and the upper bound is 41650. Okay, make sure that we have that properly. So 41600, and when we add that, we get 416,550 for the lower bound, and for the upper bound, just making sure I check properly, 41650. So 41650. Guys, I don't want to wear my reading glasses, but if I continue like this, I will have to try to use them for my next video. Okay, so there we have it for that one. Okay, so 41, something still look off for this for me, so let me just check it again. So here, 41,600 plus 50 is 41,650. So 41,650, that one is perfect. Then the next one is 41, so this 6 needs to go. So 41550. That's it. That's it. That's it. Good. All right. So moving along, we go for another bounds question. So a tank is a cuboid measuring 50 centimeters by 35 centimeters by 20 cuboid. So let's underline all of the dimensions. So all the lengths are to the nearest centimeter. That's good. So we just did some practice on that, nearest centimeter. So we know we're adding and subtracting 0.5 for each of them for the bounds. So a container has a capacity of 34 liters. 1 liter is equal to 1,000 centimeters cubed. Which has the greater capacity, the tank, the container, or can we not tell? We cannot tell. Show working to support your answer for 4 marks. Now we know this is a bounds question, guys. So what we need to do here, first thing that we need to do is to find our lower and our upper bound. Okay, so let's find the upper bound and the lower bound for the cuboid. So we have for 50, and we have for 35, and we have for 20. So we know because it's to the nearest centimeter, we're adding and subtracting 0.5 for upper and lower bound. So we need to find the upper bound, the lower bound, and see does it fit in the range, and then compare them. So for 50, let's find the lower bound and the upper bounds. So the lower bound, we are doing 50, take away 0.5, so that's 49.5. And for the upper bound, we're adding 0.5 to that, so that's 50.5. For this one, same principle applies, so this is going to be 34.5 and 35.5. And for the next one, it's 20. So 19.5 and 20.5, just to keep the upper bounds and the lower bounds in the same position. All right, now, so we're going to find the lower bound of the volume of the tank first using all the lower bounds. So 49.5 multiplied by 34.5 multiplied by 19.5, and then gets an answer for that. Then we do the same thing for the upper bound as well. So for the lower bound, let's go 49.5. We're multiplying that by 34.5, and we're multiplying that by 19.5. So that gets us 33301.25. All right, I'm just going to go straight ahead and do the conversion. So we know if we divide this by 1,000 using this conversion, we will now get it into a comparable form with the 34 liters as well. So we're just going to do this answer here, 33301.25 divided by 1,000 to get it in comparable form. So dividing answer divided by 1,000, that gets us 33.3 liters. Okay, now we're going to do the upper bound as well. So UB, taking all the upper bounds now, will be 50.5. So remember, volume, we're multiplying all 3 sides for the volume. So 35.5 and multiplying by the upper bound, which is 20.5 of the other value. Then we will have to also divide by 1,000 to get it in comparable form in liters as well. So let's go 50.5. And we're multiplying that by 35.5 times by 20.5. That gives us, so just divide it straight by 1,000 straight away. I will get 36.8 liters. Okay, so this is what we could have for the upper bound and lower bound. We compare them then. When we use the lower bound, it's 33.3, fitting in the range here for the capacity. But when we use the upper bound, it's 36.8. We could also use the actual measurement and do 50 times 35 times by 20. See what happens. So 50 times 35 times by 20, that is 3,500. And then dividing that by 1,000, we get 35 liters. So you see, guys, variation. So therefore, we cannot tell because we don't know which one of the dimensions will be used. So we cannot tell. So nice 4 marker there using your bounds. Beautiful. All right, so we move on to another question which involves pressure, area, and force. So the dimensions of a rectangular flow to the nearest 0.1 meters, very important, A force of 345 newtons is applied to the floor. The force is to the nearest 5. Beautiful. Work out the upper bound of the pressure. Give your answer to full significant figure. So they've given us the formula, which they always do. Pressure is equal to force divided by area. But we've got to use our bounds now. So this was to the nearest 0.1 meters. So what for the dimensions here? So we need to find the upper bound and lower bound as well. So we have 0.1. So it's going to be half of this. So we need to do 0.1 divided by 2. Do not take any check, guys. Put it into your calculator. So 0.1 divided by 2 is 0.05. So to the areas, dimensions of the rectangle, we are adding and subtracting 0.05 for the dimension. So let's get it for 226. So for 26, 2.6 meters, we are going to be adding and subtracting. So let's get the upper bound. So 2.6 plus 0.05 is 2.65. And the lower bound of that, we are subtracting 0.05 from 2.26. So that gets us 2.55. You see the pattern? This one always goes down by 1 for the lower bound. Now we're going to do that for 6.4 as well. So we're adding and subtracting, same thing. So just put that in your calculator. The upper bound for this one is going to be, so that would be, let's do that. So 6.4 plus 0.05, that is going to be 6.45. And the lower bound then, 1 down, 6.35. Good. So we got our bounds now, but we got to be careful. Remember, the force is 3.45, and that's to the nearest 5 newtons. So we got to do 5 divided by 2. So we're adding and subtracting to that one, 2.5. So let's do that. So 345, the upper bound of that, we're adding 2.25. So 2.5, so that would be upper bound will get us 7.5. And the lower bound of that now, subtracting 2.5, will get us 346.5. Now they've asked us to get the upper bound. Okay, so first thing we need to do is to find the area. So formula, pressure is equal to force divided by area. So what we're going to do now, we're going to find the upper bound of the area. So if we do the force upper bound here, we've got to use the upper bound because we need the upper bound of the total. And then we need the lower bound of the area. All right, so let's go for a lower bound of the area. So lower bound of area. So we're going to use the lower bounds of both measurements. So lower bound is 2.55. We're multiplying that by the lower bound of the 6.4 as well, which is 6.35. Put that into our calculator. So 2.55 times 6.35, that's equal to 16.1925. And now let's find the final answer. So pressure is equal to our force divided by our area. So we are going to use the upper bound of the force and the lower bound. Remember, a large number divided by a small number will give us the maximum output. If you're not sure, guys, do them all and choose the larger one. Okay, so we are using the upper bound of the force, which is this one. So it's equal to 347.5 divided by the lower bound of the area, which is 16.1925. Let's put that in our calculator now. So 347.5 divided by 16.925. That's now equal to 21.46. Remember, we have to pay attention. 055, they've said, give it to 4 significant figures. 1, 2, 3, 4, check. So the answer will be 21.46 since we have a 0 after, can't round down, newtons per meters squared. There we go. So remember, if you get confused, all you have to do is to do all the force that you have divided by the areas and then pick the one with the highest value. But if we think clearly, we'll see that the larger force divided by a smaller area give us a bigger answer. And then that will be the upper bound. Beautiful. Now we go to pie charts. So Chloe surveyed 120 people about their pets. How many degrees for one person? So we know the total in a circle is 360 degrees and there is 120 people. So if I do 360 divided by 120, I will get for one person. I'm always trying to figure that out first. So 360 divided by 120, that gives me 3 degrees. So therefore, if I look at my table here, I have cat 330, dog 50, fish 25, no pet 15, and that adds up to 60 altogether. So because I know I have to do my calculation, I know that each animal is 3 degrees. So I need to do 30 times by 3 to get the angle that represents on the circle. So we do 30 times by 3, that gets us 90. Then we are doing 50 times by 3, that gets us 150. Then 25 by 3, that gets us 75. 15 times by 3, that gets us 45. And now we know that that all adds up to 360. So these are the angles we are drawing. So the easiest one to draw is 90 degrees, guys. We get our protractor. We know 90 is just a cross. We label that cat. Now, be careful how you position your protractor for measuring the rest. So we've done this 90 here. So now we're going to do 150. You turn your protractor this way. Make sure the baseline of the protractor is at the center and on the line. So center here, baseline. The 0 that we're looking at is on the outside. So we are counting off 150, which is here. Put a nice little pencil mark there. Lift it up, join it in, and then that is 150. So this is 90. Good practice is to label them. This is 150 here. Now we've done that. We need to do 75. So again, turn our protractor. We are centering, making sure the baseline of the protractor is on the line of the radius that you did. This time we're using the 0 on the outside. We're measuring 75, which is halfway between 70 and 80. Then we take up our protractor, make the line, label that. This is 75. Clearly, what is left now will be 45. Position, make sure you position it properly. So that will be for no pet. And there we have it. This is how we draw a pie chart. Just in case miscellaneous this comes up, could be on paper 2, could be on 3, more likely. Okay, so finish with our pie chart now. Now we go to frequency tables. Here is some information about the marks for 60 students who took a test. So we've got our class intervals and we've got our number of people. In which class interval is the median? Circle your answer. So first of all, we know that there are 60 people altogether. So median is the middle, so it's 60 divided by 2. We're looking for the 30th value. So we got to get our cumulative frequency to see where the 30th value lie. This is 14. If I add 14 plus 18, so 14 plus 18, that is 32. So we know that all of this boundary ends at 32. So 30 has to be in this region. So it's going to be in this class interval. There we go. Nice and simple as that. Now, a very, very common question we expect to see, guys, is this one. Mean from your frequency table. So we're given, the table shows the heights of 50. So we know the frequency straight away, 50 students. We got our class intervals here. We got our frequency. We are asked in the first instant to write down the modal class. Nice and easy one marker. Remember, the mode is the one with the largest frequency. So we check. So the class interval with the largest frequency, 23, that would be, so H is, so 140, and then we got 150. So that's simply our answer, highest frequency. Now we're asked to work out an estimate for the mean height. We know it's going to be our fx column here divided by our frequency. So the total for the fx column, I can never draw this symbol properly, divided by the total frequency. But remember, I need to first of all get my midpoints. And then I'm going to multiply my midpoints by my frequency to get the fx total, and then add them all up and then divide by the total frequency, which I already know is 50. So if they didn't give me this, I would just add all these together and then I would know the total. So let's go for the midpoints. So we need to do 110 plus 120 divided by 2. So 110 plus 120 divided by 2. That gets me 115. So between 120 and 130, add them, we get 250 divided by 2. 250 divided by 2, 125. And then between 130, 145, we can see the pattern. We are going up by 10. And then the next one, then be careful and make sure that's true, is 145. And then 150 plus 160 divided by 2, that is 155. Not all the time the pattern is this clear, so make sure you check, don't assume. Now we need to multiply them together, frequency times by midpoint, and then put our answer here. So 115 times by 3, that is 345. Then 125 times by 8 is 1,000. 9 times by 135, that is 1215. And then 23 times 145 is 3335. And then 7 times by 155, 1085. So we're going to start with the bottom up since I've got this in the calculator already. So 1085 plus 3335 plus 1215 plus 1000 plus 345. That gets me 6980. Make sure you check your values properly. So now we can put this in the formula. The estimated mean will be equal to 6980 divided by the frequency, which is 50. Common mistake on this question is for people to count these values here. No, guys, we have to add them up. So let's do that now. 6980 divided by 50 is equal to 139.6. And that's our 4 markers there. Nice, sweet, clean. Make sure you can do this question, guys. Make sure you can do this question. Cannot stress it enough. Beautiful. So we go to this other question, but this time the mean is interleaved with algebra. So the group frequency table shows the marks scored by students in a test. So we got our class intervals. What do you notice now? Our frequency is in terms of x. So x for the first one, x plus 4 for the second, 2x, and then 6 for the next one. The estimated mean mark is 23. Find the value of x. So guys, we know the formula for mean is the total of fx divided by the frequency. Beautiful. So we are going to apply the principle here. So we need to find our midpoint first of all. So it will be midpoint times by our frequency to give us fx. Then we're going to set up an equation, make it equal to the mean that we're given, and solve. Beautiful. So now we need halfway between 0 and 10 here, which is 5. 10 plus 20 is 30, halfway is 15. And then 20 plus 30, 50, 25. So again, nice pattern here. 40 and 30, 70, halfway 35. Fantastic. So now I need to do 5 times x, which gets me 5x. I now need to do 15. So let's do this nicely. It's going to be bracket. Let's just put a bracket here. So 15 times by x is 15x. And 15 times by 4 is 60. Make sure that we're using our calculator to check this under pressure. Good. So for the next one, we are multiplying by 25. So 25 times 2 is 50. So this one is 50x. And then we are doing 35 by 6. 35 times 6, that's 210. So 210. Beautiful. So now I need to get my total frequency and I need to add these up as well. So total frequency, we need to do 15 plus 5 plus 25 plus 35. Okay? So 15. Okay. My total frequency. So guys, I'm adding my midpoint instead of my frequency. So let me just leave that there. Frequency will be x plus 4, 2x, and 6. And that's because I wrote on my diagram. I got a bit confused there. So these are the ones we're adding x plus 4, 2x, and 6 for our frequency. So let's keep that now for just a bit. But let's get the total of fx. So it's going to be 5x plus 15x plus 60 plus our 50x plus our 210. Let's get a simplified version of this. So 15 and 5, that's 20. 20 plus 50, that's 70 in terms of x. So that's 70x. And then I've got 210 plus 60, which is 270. So that's our total for the fx column. And we need to do that divided by the frequency. So let's get the frequencies added up together now. So that would be x plus 4 plus 2x plus 6. So this is our frequency, okay? And this is our fx. Let's make that clear. So x plus x is 2x plus another 2x, so that's 4x, and 4 plus 6, that's 10. So now let's set up the formula. So it's fx, which is this, which is 70x plus 270 divided by the frequency, which is 4x plus 10, and we're told that that's equal to the mean, which is 23. So now I just need to solve this for x. So we need to do 23 times by, so I'm multiplying these two by 4x plus 10, and that will be equal to 70x plus 270. So let's do this. 23 times by 4x will be 92x, and 23 times 10 is 230. That's equal to 70x plus 270. So I'm going to collect my like terms now. So 92x minus 70x equal to 270 take away 230. So 92 take away 70, that is equal to 22x, equal to 270 take away 230, that's just 40. So now I need to divide by 22 on both sides. So x equal to 40 divided by 22. That gets me to 1.82, and that's the 2 decimal place. So that would be the value of x. Absolutely brilliant. Again, guys, application matters. Well, you know how to find your mean, you know how to rearrange formula, and so on. So we do our fx, we divide it by our frequency. Beautiful. Now, guys, we're going to do some construction and loci. We aren't leaving any stone unturned here. So this question says, using a ruler and a compass only, construct the following side, side, side triangle accurately. A very good opportunity to review one of our congruents here, side, side, side. So we are told the equipment we need to use. Guys, make sure that you are ready for this. So step 1. So the first thing that we need to do in this question, we are going to be drawing 6 centimeters, so the base of it first with a ruler. Make sure you measure properly, so I'm going to demonstrate this for you. So here is my ruler. I need to start at 0, and I'm going from 0 to 6. I'm going to label that. The next thing I need to do, I'm going to draw 2 arcs with lengths 4 and 5 from each end of the line. So what I have to do now, make sure that I draw them on the side that they belong. If you put the 5 over here and the 4 over here, that's not accurate at all. So we take our ruler, we are going to open our compass to 4 exactly on the ruler. Once I've gotten that 4, I'm going to put my compass to the end of the line and I'm going to swing an arc. And that arc is exactly 4 centimeters. I bet you guessed it that we will also need to do the same step, but open to 5 this time. So get my ruler again, open to 5 this time. On the other end, I put my compass and I'm going to swing another arc around. So where both of the arcs intersect, that will be the vertex at the top of the triangle. So now I take my ruler and I'm going to draw up the lines connecting on both ends. So I take my ruler from the ends connecting to the vertex there and then put my measurement in. Importantly, do not erase your construction lines. We want to know that this was constructed and not drawn. So you've got to swing those arcs, nice clean pencil marks. You must sharpen your pencil so that the lines are nice and clean. Construction lines are never thick, nice, thin, bright enough. Remember, your paper will be scanned. And so when your paper is scanned, you need to make sure that your drawings can be seen. What you don't want is for you to do this, and then when they scan it, there is nothing shown when your paper is supposed to be marked. So you gotta be careful. Okay, so we draw a side, side, side triangle there. Next, we're going to use ruler, compass, and protractor this time to construct side, angle, side. Another congruence there, triangle accurately. So again, we're going to start off drawing 7 centimeters with our ruler. So put my ruler from 0, measure 7. Put that in. Beautiful. Now, this time, step 2, I'm going to draw an arc with length 8. So again, take my ruler, open to 8. I'm going to swing an arc. That will be 8. Now I've got an angle I need to measure. So I need to get my protractor. So take my protractor, put it there. Make sure the center is dead onto the end of the line. And your baseline, which is the 0 line here, must be on that line. So now I need to pay attention to the scale that I'm using. So I'm measuring 40. So that means I need to get the scale that's dead onto 0. So I'm going to mark my 40 off. So this time I have to use the inner scale because the inner scale is the one, the blue line, blue ones here, blue writing is on 0. I'm measuring 40. So I go on, mark my 40 there with a nice line. Take that up and put my angle in. Extend it all the way until it touches the line, the arc that I drew with 8. Now I'm going to connect the end of the line to the vertex there. Make sure you label everything. Beautiful here. You've got the video to do it all over again. So I draw my base, swing an arc of 8, measure an angle of 40, extend the lines, and then where they meet will be my vertex. And again, guys, never erase your construction lines. Beautiful. We move on to drawing. Using a ruler and a compass and a protractor, construct the following angle, side, angle, triangle accurately. So again, another opportunity to review another congruence there. So this time we have 2 angles to do. So like what we always do, draw our base 7.3. So 7.3 is going to be 2 off 7.5. Label that in. Now I need to take my protractor and I'm going to measure both angles. So 35, put the center of my protractor at the end. I am using the inside zeros. I'm measuring 35, which is, so 30 is here, 40 here, 35 halfway through. Make sure you follow the correct 0. So that's where I'm going to draw the other one as well, which is 52. So this time I'm using the outer scale. So I have to go to 52. So 50, 51, 52. Nice, neat line. Then I'm going to extend my lines with my ruler. So extend, then extend. make sure that you label up and do not erase your console. I'm brightening that up nice and clean so when my paper is scanned, I can see that. And do not erase your construction lines at all. Beautiful. So just to talk to you about some loci now. So when we talk about our locus, if we are asked to draw the locus from a point, the locus from a point will be a circle. So if a question says draw the locus of a point A 5 centimeters, you are opening your ruler to your compass, on your ruler to 5 centimeters. From the center A, you are making a circle. So a locus from a point is always a circle. If you're asked to find the locus of the point all equal away from a line, it's going to look like a racetrack. If you're asked to do the locus of a point equal distance from the point, from 2 points, so A and B, you are going to be bisecting the line AB to find halfway, which I'm going to show you in a bit. If you're asked to do the locus equidistant from 2 lines like we have here, basically what it is, you are bisecting an angle. So you're cutting that angle in half. I'll also show you how to do that. Also, you could be asked to draw the locus of a point equidistant from the point A and B. That is from the point that you see with the dot here. So that one I'll also show you how to do. Okay, so make sure that you know what you're asked, what it should look like. So good for you. You can even pause this. You can even screenshot it. You can take a picture and see what you're expected to produce based on the question. So here is our first question. Draw 2 points on your page and label them A and B. Join them with a straight line and construct its perpendicular bisector. Now, for this question, they could just tell you, give you the points A and B and ask you to find the perpendicular bisector. That means we are cutting that line in equal half. But because of the purpose of the walkthrough, I've structured it like this so you can draw it in. So I have A and B. I'm going to draw them in. Now to bisect this, which means to cut it into equal parts, the first thing I need to do is I'm going to draw 2 equal arcs, but I need to put my compass point on A. I'm going to open my compass to a little more than halfway between A and B, and I'm going to swing an arc around. Without changing the radius or the opening of the compass, I'm going to put that also on B, and I'm going to swing a similar arc. Beautiful. Now, once I've done that, all I need to do is to use my ruler and draw a straight line through them. You could also measure from A to the midpoint and B to the midpoint and see that they are exactly the same. Now you have bisected a line A, B. If they just gave you 2 points, you draw the line in yourself and open it, swing an arc. Watch this again and make sure that you can do this. Very common construction question there. So the line is perpendicular bisector and contains all points that are equal distance from A. So even if you should draw a point from the top here to A and from the top to B, it will be equal in distance. Anywhere on the line you pick and you go from A to B and from A to the middle, A to B, it should still be the same. So equal distance. Never erase your construction line. So here we go. Construct the line perpendicular to AB through C, which is a point not on AB. So to do this, guys, we need to use our compass to find 2 points on the line that's equal distance from C. So you're going to put your compass point at C. You're going to swing an arc around. Now, where the arc cuts the line is now your reference points. So what you're going to do, you're going to construct a perpendicular bisector now, just like you did earlier. So you're going to put your compass point on the intersection, swing an arc all the way around. Then you're going to put it on the other side where it intersected and swing another arc around. Beautiful. Now, what we need to do is to use our ruler and cut through the points there. Again, you can watch it as many times as it takes for you to get this, and also practice it at home as well. Okay, beautiful. So that's constructing the perpendicular bisector of a line from a point that is not on the line. Great. So now we're going to bisect an angle. So bisecting the angle shown below, draw an accurate angle on your page, but for the purpose of this, I will put all of this in the description of the video, so you have this as well. So you get the question done on paper. You will just be able to follow through with this as you work along with me. So in order to draw an angle bisector now, guys, we're going to draw an arc from the vertex to cut each of the two lines that we've got here. So compass point, swing an arc to cut both of the lines. Where we've intersected is our reference point. So we're going to take up our compass, put on the intersection of the arc and the line, swing an arc. Put it on the other side, swing an arc to intersect that one. These are the most common constructions you will get. Then take your ruler now and join all the way through. Now, if you measure the angles, both of them should be exactly the same. We have bisected the angle. Beautiful. Play it again, and you will make sure that you know how to do that, should in case you get constructions. Okay, so the line is the angle bisector that contains all the points equidistant from both arms of the angle. So they are equal distance everywhere you check. Do not erase your construction line, cannot stress it enough. Now we're going to do a loci question. Sam and Mia wants to live within 6 miles from Oakford and within 5 miles from Riverdale. Shade the region where they can live. It's a centimeter grid. The scale is length of 1 square is 1 mile. So what I need to do, I'm going to open my compass. So from O for Oakford and R for Riverdale. So it should be 6 within 6 miles from Oakford. So I'm going to count 1, 2, 3, 4, 5, 6 squares. I'm going to open my compass to 6 squares and draw a full circle. So opening your compass there, you're going to draw a full circle there. Beautiful. Now we are going to do the same for Riverdale. That one we need to open 5 miles. So it's going to be 5 of the small squares. So it's going to be from here, 5, 1, 2, 3, 4, 5. So we're going to open it to 5, swing an arc all the way. It should be 5. Now it says it has to be within 6 miles away from Oakford and within 5 miles away. So the point on this board that is within, it has to be in the circle for 6 and also in the circle for 5. So it's that bit there that we need to shade. That's where they can live. So it's the intersection of both of them. This question is very, very, very common. You may see it on paper too. Okay. Now we go for another question here. A new supermarket is going to be built. It needs to be closer to Crystal Palace than to Peckham, within 3 miles of vertex view. So when a question says it is closer to one place than the other, we are talking about the perpendicular bisector of that line that connects those two places. Okay, so closer to one section, we have to bisect the line, and it's closer to the one than to the other, which they have stated. So the first thing we're going to do is to draw the perpendicular bisector C for C and B. So just like we bisected the line AB, we're going to be opening our compass to more than half the line and swing an arc. Then we're going to do it from P and swing another arc. Then we're going to cut it down the middle. So first arc, you could do it all the way around if you wanted to. And then we need to put it on P and draw one around, and then cut it down. So it says closer to Crystal Palace. So we know it's going to be on the left-hand side of this line that we drew. But now it should be within 3 miles of vertex view. So again, we need to get a circle that is 3 miles. So we're going to do 3 squares along for vertex view. 1, 2, 3. So we'll open our compass and draw a circle, which is 3 in radius. So you can see from here, 1, 2, 3. Okay, so if it has to be within the circle for 3 miles, but closer to C than to P, then it must be this region that they're asking me to do. And once you can break it one step at a time, guys, you will have no more problem with loci. Beautiful. Okay, next question says that the map shows the positions of 2 schools, Alfred and Bancroft. A new school is going to be built. The new school will be less than 5 kilometers from Alfred, and it will be nearer to Bancroft than Alfred. So again, nearer, perpendicular bisector. Shade the region on the map where the new school will be built. So let's go back for criteria. The new school will be less than 5 kilometers from Alfred. So we'd have to draw that locus of a circle from Alfred. It says the scale is length of 1 kilometer for 1 square for every 1 kilometer. So it's 5. We're drawing 5 squares. So we're going to open our compass to 5. So and draw the circle. 1, 2, 3, 4, 5. Dead on. Okay. But it says that it will be nearer to Bancroft than to Alfred. So we now need to make the perpendicular bisector from the line A to B, which you could draw in. So that's what it looks like. Okay, in the interest of time, we've done a few of this, so you should be able to bisect a line from A to B now. Beautiful. Now, shade the region on the map where the new school can be. So it says it has to be less than 5, so within the circle, but it should be nearer to Bancroft, so it's going to be on the right this time. So it's that region. The school can be built there. And this is application to real life. This is how people position schools and supermarkets and stuff so that it serves appropriately to communities without making one have to go too far and the other one has it closer to them. Okay, so now we move on to volume. So we're going to look simply, let me just get my calculator ready again. Okay, so now we are going to be doing a little bit of conversion. Conversion of square and cubic unit often get people in trouble. So we're asked to circle the volume that is the same as 15 centimeters cubed. We recognize everything is in millimeters here, so we're going to need to do a conversion from centimeters to millimeters. So 10 millimeters equal to 1 centimeter, but we are converting cubic units. So I have to cube both sides to get the cubic conversion. So 10 cubed is 1,000. So 1,000 millimeters cube, 1 cube is the same as 1 cube, so that side doesn't change. So now I'm converting from a larger unit to a smaller unit. So I need to multiply. So I'm going to do 15 multiplied by 1,000. So that is equal to 15,000 millimeters cube. So it is therefore my first option. Beautiful. So remember, linear components, if you're just converting from centimeter to millimeter, 10 millimeter, 1 centimeter. If it's area, you have to square both sides to get the square conversion. But if it's volume, we have to cube both sides to get the cubic conversion. So next question says, circle the area that is equal to 36 millimeters square. Very good way to do our conversion for the area square units as well. So again, millimeters, all of the answers are in centimeters. So again, 10 millimeters equal to 1 centimeter. So I need the square conversion. So I have to square both sides. So 100 millimeter. Let me just erase this, guys. No confusion around here. So 100 millimeters squared is equal to 1 centimeter squared. So I'm going from the millimeter, which is a small unit, to a large unit. I need to divide. So 36 divided by 100. 1, 2. So 0.36. I look for my answer. It is indeed the last option. Beautiful. Now we go for part C. average speed is equal to distance divided by time. If the distance is halved and the time is doubled, what happens to the average speed? Circle your answer. So guys, let's start off with distance being 60 and time being 30. So 60 divided by 30 is our original here. This is equal to 2. Let's see what happens if we follow this criteria. If the distance is halved, then we now have 30 divided by, if the time is doubled, we will then have 60. So this is equal to a half. So what has happened? What is the change from 2 here to a half? So from 2 to a half, 2 multiplied by a half here, we can see, 2 divided by a half, keep, change, and flip, that's equal to 4. So basically what has happened is that we have now divided that by 4. It has been divided by 4. Beautiful. Okay, now we go for this question. We're told that Tom and Adil are 2 runners in a 200 meters race. Tom completes the race in 24 seconds. Adil completes the race at an average speed of 28.8 kilometers per hour. Okay, so this one is in seconds, this one is in hour. Who wins the race? So first thing, we know that speed is equal to distance divided by time. So what we're going to do is to work out this one, Tom's one. So Tom is equal to distance he covered, 200, divided by the time, which is 24. We got to remember this is in seconds, however. So let's put that in our calculator. 200 divided by 24. That gets us to 8.3, and this is meters per second. So now what we need to do is to convert the other one as well into meters per second. So kilometers, 100 meters. So going from meters, it's not 100, it's 1,000. 1,000 meter is equal to 1 kilometer. So we're going to convert the kilometers here into meters so that they will be in meters per second. And we're going to also making sure that we go from an hour to seconds as well. So we're going to do 28.8 times 1,000. Making sure that we put that correctly in our calculator. So that's 28800. Don't take any chances. It's a non-calculator paper. Then you have to 1, 2, 3. But calculator, just put it in the calculator, guys. All right, now, so this is our distance in terms of meters. So I need to get my hour as well in terms of seconds. So we know 60 seconds make a minute. So 60 times 60. 60 times 60, that is 3,600. And so then I'm going to convert this one so that they are comparable. So I'm going to do distance, which is 28800, divided by the time, which is 3600. So 28800, I'm dividing that by 3600. That's equal to 8. So 8 meters per second. And it say, who wins the race? I know you're tempted to think it's the one with 8 because we're talking about running. But you have to look at who covered the most distance in the shortest time. So Tom wins the race because he covered 8.3 meters per second, while Adil only covered 8 meters per second. Okay, so Tom's win. You can also qualify that to say more distance per second. So he did more distance per second. That's why he won. Very tricky, and these can catch you out as well. Okay, so now we're going to look at this question. A car journey in 2 stages. Stage 1, the car travels 110 miles in 2 hours. Stage 2, the car travels 44 miles at the same average speed as stage 1. Work out the time for stage 2. So if it's the same average speed as stage 1, I have to ask myself, do I know the average speed for stage 1? And no, I don't. So I need to calculate it. So we know speed is equal to distance divided by time. So it's going to be 110 divided by my time, which is 2 hours. So 110 divided by 2, not taking any stops here, guys. I'm using my calculator. So that is 55 miles per hour for stage 1. Okay? So stage 2, we know it's the same distance. And it says that the car travels 44 miles at the same average speed at stage 1. So that's the speed. And I need to work out the time. And I need to give that in minutes. So we know time is going to be equal to the distance divided by the speed. So it's 44 miles. So it's going to be 44 divided by the same speed here, which is 55. So now I need to do 44 divided by 55. Put that in our calculator. 44 divided by 55. And that's equal to 0.8, but that's in hours. The question tells me to give my answer in minutes. So I need to multiply this by 60. So 0.8 times by 60. So I've got this in my calculator, just do times 60. That's equal to 48 minutes. Absolutely brilliant. So I had to use the speed from stage 1 since it's the same speed for stage 2. And then I manipulate my formula. Speed is equal to distance divided by time. So time is equal to distance divided by speed. But pay attention to the accuracy. I want to calculate this in minutes. But when I divide this, because it was miles per hour, I would have been getting 0.8 in terms of hours. Now I have to multiply that by 60 to convert that to minutes. Absolutely brilliant. Well done, guys. You are becoming brilliant by numbers. Beautiful. So now, guys, we are going to look at compound measures. Here are two solid cubes, x and y. The mass of x is 10.976 kilogram. Make note of the unit. The area of each face of x is 784 centimeters squared. So the area of each face, it's a cube, so all the faces are the same. Now, the mass is what we were given. They've just put that back here to remind us. Zion wants to know the density of y. He assumes that y is identical to x. What density should he get for y? Give your answer in grams per cubic centimeters. That is very, very important. So first of all, we now need to focus on finding the mass. So we're given the mass for x. We need to find the density for x. And if we have, because of the assumption he's made that they're the same, that means that would also be the answer for y. So let's get our formula down. So density, we know mass is at the top of our triangle. So mass at the top and then density and volume. So we know density then would be equal to mass divided by the volume. Beautiful. So information we have here, we know we want to find the volume of this shape. So we got the mass already. We need the volume before we can find the density. Key piece of information here is that the area of the face of this is 784. So we can find one of the length of the side of the cube by doing the square root. So if the area, which is side times side, gives 784, then let's just call the length here x. So x then would be equal to the square root of 784. Put that in our calculator. So square root 784. And that gives us 28. So we know that one side here is 28. So now we can find the volume because it's a cube. So all the sides are the same. So the volume of the cube is equal to one length cubed. So 28 cubed. Put that in our calculator. So we got 28 in our calculator as well. We just need to cube that now. So 28 cubed, that gives us 21952 centimeters cubed. Brilliant. So now that we found that, we need to focus on the information. The information tells us we need the density, but we need it in terms of grams per cubic centimeters. So this is already in cubic centimeters. By the way, centimeters is compatible with grams and meters with kilograms. So either way, we would have needed to do some conversion. So we're going to convert our 10.976 kilograms to grams. So let's go. 1,000 grams is equal to 1 kilogram. I'm doing 10.976 and I'm converting from a large unit to a small unit. So I need to multiply. Okay, so large to small, we multiply. So I'm converting this by multiplying by 1,000. So 1, 2, 3. If you're not sure, put it in your calculator. So 10,976. So that's our conversion. So now that we have compatible units, we can now go ahead to work out the density. So density is equal to the mass, which is now 10,976. We're dividing that by the volume, which is 21952. So let's go. 10,976, and we're dividing that by 21952. And that works out to be 0.5 grams per centimeters cubed. And that's our answer. So we always check the compatibility of our units. Absolutely fantastic. Nice and easy, 4 marks there. We move on to another compound measure. So Ralph has an iron. He models the base of a triangle joined to a trapezium. So this is the iron, this is the model of it, not drawn accurately at all. So in part A, the iron applies a force of 25 newtons. Pressure is equal to force divided by area. Work out the pressure using Ralph's model. So pressure is equal to force divided by area. So what I've got here is the force, which is 25. I now need to find the area. But the area would be the triangle plus the trapezium. So let's go for the area of the triangle. Area of triangle is equal to base times height divided by 2. So that gets us to base is 10. And the height here is 8, so 8, and then we need to half that. So 80, that's nice to do without the calculator. So that's 80 divided by 2, so this is 40 centimeters squared. Now let's find the area of the trapezium. So the area of a trapezium we know is half A plus B times by the height. So I'm going to substitute A and B for 10 and 13. So it's half of 13, or 10 plus 13, doesn't matter which way, times by the height, which is 12. So we put that in our calculator. So half bracket 10 plus 13, and then multiply that by 12. And that gets us 138 centimeters square. Beautiful. So the total area is equal to, we got this in our calculator now, so we just add that to the 40, so plus 40. So 138 plus 40, that is 178. Beautiful. So we've got everything we need now. We got our total area and we know the force. So let's go. Pressure is equal to, my force was given to be 25. We put that in, divided by my area, which is 178. So let's go. 25 divided by 178, and that's equal to 0.14 newtons per centimeters squared. Absolutely fantastic. So it's that clear, logical thought. Just put in everything that I know. Now to find the area of a triangle, now to find the area of a trapezium, we add that together. But let's see what we notice, because we got a part B for this question. So part B say Ralph has an iron, so the same model. Now part B says, is the actual pressure greater than, equal to, or less than the answer in part A? So let's have a look at what goes on for the actual thing. If you notice here, we hadn't found a real accurate measure of the area because the bottom bit here was unaccounted for. So that means the actual area would be greater. And if the actual area is greater, that's going to affect the outcome. So the outcome will then be smaller. So therefore, we need to say it's going to be less than. And it says give a reason for your answer. And your reason will be the actual area in part A is larger. So the actual area in part A is larger than calculated. Okay, or than was calculated. Make it nice and pretty. There we go. All right, so it's going to be less, because if the area is bigger, then when we divide by a bigger number, we'll get a smaller value. Beautiful. All right, now, so we go for area, volume and of prism, scale factors, and so on. So prism A and B are similarity is what I'm after. The cross sections are shaded. So we know the cross section here, which is the area. Don't know it for prism B, but I know the length of prism B. So the area of the cross section of prism A is 32 centimeters squared. The length of prism B is 18 centimeters. The volume of prism A to the volume of prism B is 8 to 27. Work out the volume of prism B. So we know volume is equal to cross-sectional area, so it's the shaded bit, multiplied by the length that was given here. So what we're missing from this one is the cross-sectional area. We have the length already, but we have enough information that we can use, because we know that the volume of A to the volume of B is, so the volume of A to volume of B is equal to, so this is supposed to be A and B. Okay, volume of A to the volume of B is 8 to 27. So I'm going to need to find, I can use this because what I want is the area of the cross section of B. So what I can do here is to find the cube root of these, and that will give me the linear scale factor, and then I square it to get the area scale factor. So the cube root of 8, you put that in your calculator, that's 2. The cube root of 27 is 3. So the linear scale factor, let's write that down, LSF is equal to 2 to 3. But I need the area. So what I'm going to do, I'm going to square these. So the area scale factor would be equal to 2 squared to 3 squared, which is 4 to 9. So I know the area, cross-sectional area of A is 32, so that matches here. So 32 matches the 4 parts. That means I need to multiply this. So 32 divided by 4 is 8, so this is times by 8. I also need to times 9 by 8. 8 times 9 is 72. Clearly, we will be doing this with our calculator. I'm just showing off that I really do know my timetable. Hope you do too, but don't do it on a calculator paper, guys. Put it in the calculator. So this one is 72. Beautiful. Now I have enough information to find the volume of B. So volume of B will be equal to the cross-sectional area, which is 72, multiplied by the length, which is 18. Let's put that in our calculator. So we get 72 multiplied by 18, and that's 1,296 centimeters cubed. 4 marks. Absolutely fantastic. So we know how to find our linear scale factor. We know how to find our area scale factor. We just need to ask ourselves the relevant questions. Listen to the questions I ask you, and in that exam, hear me talking to you and asking you those questions as well. And once you answer them in a clear, logical way, guys, you will pick up these marks. Beautiful. So we go on to cylinders. So here are 2 cylinders, cylinder A, cylinder B. We see the dimensions. Both of them have the same diameter and 2 different heights, 13 and 21 respectively. So cylinder A is placed on top of cylinder B to form a new cylinder. Work out the surface area of the new cylinder. Give your answer to 4 significant figures. So the first thing we need is the formula for the surface area of a cylinder. So that formula is the surface area is equal to 2 pi r h plus 2 circles. So one circle is pi r squared, and we need 2 of them, one from the top, one from the bottom. Remember, the one in the middle would not be seen. So it's 2 pi r squared. So therefore, we know the radius, because if we know the diameter across is 18, then the radius is going to be half of that, which is 9. So now all I'm missing is the height. So I know the height of the first is 13 and the height of the second is 21. So adding them together, 13 plus 21, that's equal to 34. So I've got 34 here for the total height. So now I'm just going to substitute into my formula. So I'm going to do 2 times by pi times by the radius, which is 9 for r, times by the height, which is 34. Then we need to add that to 2 times by pi, and the radius is 9. Don't forget to put your square, common mistake. So let's put the first in the calculator. So 2 times by pi times by 9 times by 34. And that gets us 612 pi plus 9 squared is 81 times 2, guys. So that's going to be 162 pi. That one I could just do in my head, but you shouldn't. Make sure you put it in the calculator. So 162 pi plus 612. Do you know that is the same numbers but swapped around? Yes. So adding them together give us 774 pi. And then the question asks us to give it to 4 significant figures. Let's press SD. And we have 2431.592. So 4 significant figure, 1, 2, 3, 4. Check the one behind. We need to round up. So it's 2,432 is our answer. And that's the 4 significant figures. Beautiful, 3 marker there. We move on to surface area. So the cross section of a prism is a right angle triangle. So we can see the cross section here. Usually they'll put this in if you were to find the volume as well. Work out the surface area this time. So 4 marks, not accurately drawn. So I need to find the surface area, means the area of all the faces added together. So I'm going to do, I've got 2 identical triangles. Let's call that 1 and 2. So I'm going to find the area of the triangles first. So since it's 2 triangles, guys, it will be like a rectangle. So I don't need to divide by 2 and then double again. I could just do base times height, and that would be both of them together. So area 1 and 2 is equal to base times by height, and the base is 12 and the height is 5. So 12 times 5 is 60 centimeters square. We've taken care of 2 faces. So now we're going to do the face at the back, which is face 3. So area 3 is equal to, so we got 5 down and 10 across. So 5 times by 10 is equal to 50 centimeters squared. So now we need to do face 4, which is the one on the floor here. And so area 4 is equal to, so let's check, we got 12 by 10. So that's 12 by 10, which is 120. Nice soft numbers there. Now we need to do the one on the top. Many people forget this one on the top. So area 5 will be equal to, so that's 10 and 13 on the side. So 10 times by 13, that's 130 centimeters squared. Now the total surface area is equal to, adding them all together, put that in our calculator, I get 60 for the first, so tick that off as we go so we're not confused. Then we need to add that to 50, tick that off, plus we are doing 120, tick that off, and then 130. So let's put that in our calculator now. So 60 plus 50 plus 120 plus 130. And that gets us 360 centimeters square. Absolutely brilliant, guys. So moving to the next question, which is on frustrums. So a frustrum is made by cutting a small cone from the top of a large cone as shown. So we've got the large cone here, and we've cut off the top of it. So the radius here we can see 6, slant height is 15, and this is our frustum now. So the slant height of the large cone is 15, that's just reading the diagram. The radius of the base of the large one is 6. The height of the small cone is half the height of the large one, okay? And we are asked to work out the curved surface area of the frustum here. So the question is, if the height here is half, so it says that this one is half the height, so let's put that in. So it says the height of the small cone is half the height of the large cone. The question is, do I know the height of the large one? That's a good question there. Okay, so now we need to find out the scale factor. So since this is half of it, the scale factor that links the small one to the large one is 2. So scale factor would be equal to 2. That's key information here. So we've used that bit of information there. So now we can use that information to find the slant height of the small one as well. So slant height of small would then be equal to the slant height of the first one, which is 15, and we're dividing that by 2 as well. I'm just using my calculator to avoid error. So that would be equal to 15 divided by 2. That is equal to 7.5. Beautiful. So now, if you can see here, in order for me to find what I was asked to do, I have to do the large curved surface area, take away the small curved surface area. So basically, I've cut that off. If I find all of the large one, then take away the small one, that will be the curved surface area for the frustum that's left. Beautiful. So let's write that down. So large curved surface area, take away the small. Okay, you can write curved surface area as well. So the area is equal to pi r L. Okay, so we're going to do that for both of them and then take it away. So I know pi is fixed, I know my radius is 6, and I know the slant height is 15. So pi times by radius 6 times by slant height 15. Let's put that in our calculator. So pi times 6 times by 15. See what we get? We get 90 pi. So we're subtracting that, same formula now. So pi times by r times by L. So take away pi times by the small radius. Remember, it was half as much, so that one is 3. We didn't put it in, but yes, it's 3. Times by the slant height for that one we got was 7.5. So put that in our calculator now. So pi times by 3 times by 7.5, and that gets me 22.5 pi. So let's take that away. So 90 pi, take away 22.5 pi, that gets me 67.5 pi. Press the SD button and see what I get. I get 212.057. I'm just going to round it to one decimal place, so 212.1. And that's our answer there, okay? So talk yourself through the question. Think about a birthday cake. I chop this piece off. I want to know the curved part. I need to find the curved part of the full one, the curved part of the small one. Subtract them will be what is left of the frustum. And if you are asked to do anything else concerning that, that's a line of thought you should have as well. Beautiful. So now we go on to the next question, where we're told that a bowl contains 5,000 centimeter cubes of air. More air is pumped into the bowl at a rate, so this is what is contained. More air is pumped into the bowl at a rate of 160 cubic centimeters per second. The bowl is full when the air becomes a sphere with radius 15 centimeters. So we're giving here the volume of a sphere, 4/3 pi r cubed, and the radius is r. So, okay, so r is the radius. Does it take less than a minute to fill the ball? You must show you're working for 4 marks. Beautiful. So the first thing to do here, we're going to use our volume formula to see how much air is in the ball when it's full. So it becomes a sphere when it's filled. Okay, so let's go. So we're going to have 4/3 pi r cubed. Okay, so let's put that in. So 4/3 multiplies, so I'm going to put that in my calculator. So 4/3 times by pi and times by, I'm using my radius here, which is 15 cubed. So times by 15 cubed, and that's equal to 14.137. Good. Now, this is what it's filled, when it's filled all the way up. But remember, the ball had already 5,000. So to know how much was added to that, we now need to do 14,137, take away the 5,000 that was already in there. So since we got that on our calculator, let's now subtract this. So minus 5,000. That's equal to 9137. Beautiful. So now we need to find out, the rate at which it was being filled here. We were told is 160. So now we need to do 9137 divided by that 160, which is per second. So divided by 160. So let's see what that gives. So 9137 divided by 160. So that's the rate at which the ball is filled. So that is 51.1. So we now need to compare that with a minute. A minute is 60 seconds. So this one is in seconds because that's what we were given. So we can see 60 seconds is 1 minute. So just let's write 1 minute equal to 60 seconds. Your examiner wants you to see comparable form. So now we'll say 57.1 is less than 60 seconds. So it asks us, did it take less than a minute? The answer is yes. Yes, it takes less than 1 minute. Make sure you answer 1 minute, sorry. Let me just cross that off. Make sure you answer intelligently, guys. Okay, so yes, it takes less than a minute. Tick that off. There we go for that question. Now we move on to bearings. So J and K are ships. P is a port. J is due south of P. Angle JPK is 56. That's just telling us about the diagram here. JP is equal to KP. Okay, so these are put in for us on here. So clearly, we could see that even if we were not told. We're asked to work out the bearing of J from K. Now, when we talk about bearings, we always start at the point that comes after the word from. So from K, we are going all the way around to J. So that's the angle I need. So that clearly, if I find these angles here and take it away from 360, I would have found what I was asked to do. Now, because these two lines here are parallel, this now forms an alternate angle. So this angle here is 56, which you could put in on your diagram. Now I can find one of the base angle here by doing 180 take away 56 and then split that in half. So let's go. 180 take away 56 divided by 2 will give me the angle here. So let's call it x. So x is equal to, so let's put that in our calculator. So 180 take away 56. Bear with me, guys. So 180 take away 56. I now need to divide that by 2. And dividing that by 2, I get 62. So I put that on my diagram so I see clearly what's going on. So therefore, I can find the bearing of J from K. So bearing of J from K is equal to 360. Take away the sum of 62 and 56. I could just do 360, take away 62, and then take away 56 as well. And so this is 118. So 360 take away 118. And that's equal to 242 degrees. Absolutely brilliant. Okay, guys, so we go on to sets and Venn diagrams. Awesome, we are getting there. So What does A union B, so this means union, represents in the probability of A union B? So remember, this is what it looks like. A union B is everything in A and B. So therefore, it's, if we check, A or B or both, not A and not B, that's not true. A but not B, that's not true. A and B would have been in the middle. So it's the first option. It's either A or B or both of them. Beautiful. So part B says circle the expression that means the probability of A and not B. So if it's A and not B, it's just here. So that's A and B. So it will be just here. So A and not B would be the complement of A, of B, the complement what's not in B, intersecting with A. So let's look for that. So it is A intersecting with the complement of B. So it's the last one here. Okay, next one, we are given shaded region. So which of these represent the shaded region? Circle your answer. So the first one says B. Is that just B? Next one, A complement union with B. A complement intersect with B, or A complement. So a good way to do this is to put numbers in them. So we're going to look at what is not in A. So A complement is equal to, what's not in A is 3 and 4. Let's look at what is in B. So what is in B is 2 and 3. So we're looking for the part where this is 3. So that is the part that's common to both of these. So A complement is intersecting with B. That's the answer we're looking for. So A complement, what's not in A, where does that meet with what is in B? And that's A complement intersecting with B. Okay, so next one we go for is this one. So which of these represent the shaded region? Circle your answer. So we can see clearly it's the intersection of A and B. Nice and easy one there. So we circle that and we move on. Okay, now we go for another question, which is this one. So what do we have here? So for this question, why do I feel like this one is a repeat? Let's just check back quickly. So no, this is where, so this one, I think I've made an error here, guys. So let me just check back quickly. So this question, A or B, good. And then this one is the shaded region for this one is only the white bit is shaded. So it's everything outside of that. So sorry, guys, this one is A complement. I was mixing up myself there. And then we've got A intersect B. So that's A complement and A intersect B. For some reason, I don't know why I'm looking for just this bit here, but all of A is the only thing not shaded, everything outside of that. So it's A complement. So let's just scratch that from here. So get this bit off. Beautiful. So now we need to go to, so I'm going to just move along here and so that we get more practice in, but let's do these two questions quickly and move. So for this one, we have just this bit in A only that's shaded. So if I check the shaded region only, here is where I wanted to put numbers. So 1, 2, and 3. So if I look for the elements in A, it will be 1 and 2. If I look for the elements in B, that will be 2 and 3. So the region that's shaded here is everything that's not in B. And where does that intersect with what is in A? So therefore, it's A only. So it's going to be where B complement intersects with A. Or we could say A intersect with B complement. So it's this one. Now we go on for the next question. So we can see for this one, the only thing that's not shaded at all is the union of A and B. So everything outside of that is the complement. So that one is A union B complement, which is the first option. Beautiful. So now we are going to move along and we go for another Venn diagram question. So Venn diagram, Clive owns two coffee shop A and B, work out 150. I'm rushing now, guys, because I know the video is very long and I want to get to the end. So let me calm myself down. So Clive owns two coffee shops, A and B. Out of 150 people, 18 people use both shops. 46% use shop A, 2/5 use shop B only. That's important. Complete the Venn diagram to represent the information. So this here means the total in everything. The universal set is 150. And people in A, people in B, there. So we go back to our data. We're told that 18 people use both shops. That is the intersection. Beautiful. 46% use shop A. So that's a total of everything in A will be 46%. So we need to find 46% of 150. So let's go. We're going to use our multiplier here. 46% is 0.46. We need to multiply that by 150. So let's go. So 0.46 multiplied by 150. So that's equal to 69. So that means everything in A should be equal to 69. We know 18 of that already. So 69 take away 18. So let's do that. 69 minus the 18, that's equal to 51. That goes here. Beautiful. So we check that off. Now we are told that 2/5 use shop B only. So this bit here will be 2/5 of 150. So 2/5 multiplied by 150. So let's just do that quickly. 2/5, can use our fraction button, times 150. And that's equal to 60. So 60 is B only. That's there. Now we can find the last bit by doing 150 take away everything else. So 150 take away 51 plus 18 plus 60. So let's go. So 150 take away bracket 51 plus 18 plus 60. And that gets us 21. So that goes here. So guys, you can check quickly. When you add all four bits together, you should get 150. Beautiful. So that's a total. Now I go to a probability tree. So we're told that a test consists of two sections A and B. 85% of people pass section A. So we got section A. 85% of the people pass section A. 78 of the people who pass section A also pass section B. Then 36% of the people who fail section A also fail section B. So complete the tree diagram. So guys, what we're going to do, we're going to focus on one bit at a time. So 85% of people pass section A. So pass in section A is 85%, which we can write as 0.85. So now we know probability adds to 1. So 1 take away 0.85, and that's equal to 0.15. Make sure you put it in your calculator, don't make the mistake. Beautiful. So here, again, we know probability adds to 1. So we now need to do 1 take away 0.78. Let me just keep practicing what I'm telling you to do. So 1 take away 0.78. That's 0.22. Beautiful. So now we go back to the last bit of information. 36% of the people who fail, so 36% of the people who fail section A also fail section B. So this bit for fail is 36%, which is 0.36. So therefore, I need to subtract this from 1. So 1 take away 0.36. Make sure you put it in your calculator to avoid error. So 1 take away 0.36, and that is 0.64. So 0.64 goes here, and therefore we have completed our diagram for 2 marks. Absolutely brilliant. Okay guys, so we're going to go on to another question. We're told that in a class there are n boys. Beautiful. A total of 25 students altogether. 2 of the students are chosen at random. The probability that both students are boys is 7/20. Work out the value of n. So when we multiply the two probabilities, it should be equal to 7/20. So first one, n boys out of the total 25. That's going to be multiplied. So remember now, we have taken one of the boys away. So now for the second option, it's going to be n minus 1. But we have lost one boy because we picked him already. So denominator goes to 24. So now when we multiply these two together, it should give us 7/20. So let's simplify. We now need to do n times n, which is n squared, and n times by minus 1, which is minus n. So multiply the denominators together. Let me use my calculator for that. So I need to do 25 times by 24. That gets me to 600. And that's equal to 7/20. So I'm going to cross multiply now. So 20 bracket n squared minus n will be equal to 7 times 600. Let's just do that straight away. So 7 times by 600, that's 4,200. So expand the bracket now. 20 times n squared, 20n squared. 20 times by minus n is minus 20n. That's equal to 4,200. I could have just brought this over straight away. We can see it's a quadratic. So 20n minus 20, so 20n squared minus 20n minus 4,200 is equal to 0. So guys, you can see here, we can divide everything by 2 to make it simpler. So I get n squared here minus 10n, and then 4,200 divided by 2, that's 2100. So we can either use the quadratic formula now or factorize. I'm going to choose the factorize. So 2 factors of 2,100, that gives me minus 10. So we're going to have n in both brackets as we know. So one of them will be minus 15 and the other one will be positive 14 equal to 0. We know it's an integer. So this here n is equal to 15 and n is equal to minus 14. Clearly we cannot have negative people, so we've got to use the positive one. So n therefore is equal to 15, and that brings the curtains down on this probability, interleaving quadratics as well and factorizing and solving them. Absolutely fantastic 4 marker there. Beautiful. Here is a sketch of the graphs of y equal k to the power of x and y equal x squared plus c. K and c are positive constants. Work out the value of r. So let's have a look where r is. So r is in this one here, which is on the line or on the curve y equal x squared plus c. So guys, we got to look to see what point do I know both x and y for that I can substitute to close my gaps. So if I look here on the curve y equal x to the power k to the power of x, I know the coordinates for x here. So x is 4 when y is 81. So if I substitute that in the equation here, I can work out what is the constant k. So let's go. So y equal k to the power of x. So using the coordinates 4 and 81, y is 81. 81 is equal to k. I don't know what k is, but I know x is 4 to the power of 4. So I can solve this by doing the opposite of power of 4, which is cube root. So I then need to find the cube root, the fourth root, of 81. And I'm going to do the fourth root of k to the power of 4. So this gives me k, and the fourth root of 81, don't take any chances. Fourth root 81, that's equal to 3. So we know that k is 3. So I can go ahead and substitute the value of k here. So I know that y will always be equal to k, which is 3. So 3 to the power of x. Therefore, I can go ahead now and I can find the common point here. So this is an intersection, which is a common point on both of my curves there. So if I substitute this in, I will also have a common point on the other one. Now I can fill some gaps in for my equation here. So let's go. So when we've got x to be 2, we can work out what p is. So if x is, and that would be the coordinate of y. So substituting into this, p then replaces y. P would be equal to 3 to the power of when x is 2. So we're using 2 and p. So p is equal to 3 squared, which is 9. So let's put that here, 2, 9. Now I have got a common point on this curve, so I can use it to find out the constant c. So let's go, y equal to x squared plus c. So using the common point, when y is 9, 9 is equal to x is 2, so that's 2 to the power of 2 plus c. So I can find that by doing 9. 2 squared is 4, so I'm going to be, so let's just write that down, 4 plus c. So taking away 4 from both sides, 5 is equal to c. Absolutely brilliant. So I can fill that in this equation. So y then will always be equal to x squared plus 5. Brilliant. Very close now to finding my answer for r. So r here represents x. And I've got 43.44 for y, so let's substitute. 43.44 is equal to x squared, and x in this question is r. So r squared plus 5. So to solve this, take away 5 from both sides. So 43, so let's do that. 43.44, take away 5. That's equal to 38.44, and that's equal to r squared, because that cancels out. Now I need to do the square root of both sides. So I've got my answer there. So let's do square root of answer. So r then would be equal to 6.2. And there we have it. It's that clear logical thought, step by step, and linking what I've got on the diagram. Absolutely brilliant. So now guys, after a long day of recording, we are now at our final few questions, and it's going to be on vectors. I couldn't leave vectors off. Surely we know vectors pops up all the time. So in triangle JKL, M is the midpoint of JK. So midpoint of JK, we know it's halfway along. That's important. JN to NL, so JN to NL is in the ratio 3 to 2. So K to L is 7A, which is just talking about the diagram. And then N to L is 4B. So that's here. So we are asked to work out JM in terms of A and B and give your answer in its simplest form for 3 marks. So we're going to have to use some information we're given. Key point here is that JN to NL is 3 to 2. What we do know is N to L. So we can use that and find out what is J to N. So let's go. So we know this one, N to L is 4B. So how do we get from 2 to 4B? We multiply by 2B. So same principle apply here, times by 2B, we get 6B for JN. So we put that in. So 6B, arrow goes there. So marks already on the way. But remember, we are working out J to M. So to get from J to M, remember, vectors is plotting our route. So to get from J to M, we need to go J to M, L, and then from L to K, and then we can go, so that would be our answer. So J to M would be from J to L here, then from L to K, and then we need to go halfway here, and then that would be from J to M. But clearly, we need to find out what is JK, this line here, we need this bit here, so that we can work out what is halfway, because we won't go all the way. We're going from J to M, just halfway. Beautiful. So we need to work out what is JK. So from J to K will be J to L plus L to K. So let's go. So J to K is equal to j to L plus L to K. Beautiful. So remember, if we're going in the direction of the arrow, we are going to have positive. Going against that, we are going to have a minus. So let's go. From J to L would be 6b plus the 4b, plus if I'm going from L to K, I'm going against the arrow, so that's going to be minus 7a. So let's put minus 7a here. So let's simplify this. This will be 10b minus 7a. Beautiful. So we've got that bit sealed now. So that is the answer for J to K, but this bit is just halfway. So we can just go straight ahead and divide this by 2. So 10b minus 7a divided by 2. So this will be 5b and then minus 3.5a. So we're going to put that down because this is the information we're following, that this is the midpoint. So this bit is going to be, so let's write it on the diagram. So 10b, so all the way here was 10b. So this is 5b minus 3.5a. Beautiful. Now we have all of our information. We now need to find our final answer. So it asks us for J to M, and we know this bit here is the same. So 5b minus 3.5a. So therefore, once we have found this bit, we've also found the other bit since it's the midpoint. So therefore, that's also our final answer. Beautiful. Okay, so we talked back through that. We needed to go from J to L, then from L to K to find the distance from J to K. And then halfway is the midpoint, so we just needed to divide that by 2, and that's our final answer. Beautiful. Now we go to our second to last question, and then we wrap things up. So 5 points are connected by vectors. So here are our 5 points. D, H, G, E, and F. We're told that F to G is equal to 2 times of E to H. So F to G is equal to 2 times of E to H. So clearly, we're asked to work out what is FE in terms of A and B for full marks. Guys, I kid you not, I'm very, very tired now, so I'm pressing on. So in order for me to find FG, since it's double EH, stands to reason we need to work out what is EH first of all. So I need to find the vector E to H. So to get from E to H, I have to go via ED. So that's equal to ED plus DH. So let's put that in. We're going into the direction of the arrow from E to D, so that's just 3A plus B, plus we're going again in the same direction of the arrow, so A plus 6B. So collecting like terms, 3A plus A is 4A, and then B plus 6B is 7B. There we go. So we can write this in. So it was E to H, so arrow goes here, E to H this way. So that's equal to 4A plus 7B. Now remember, we are told that FG, which is this one, is 2 times of EH. So we just need to double this. So let's just write that down. So 2 times by 4A plus 7B. So this will give us, multiplying out, we get 8A, and then plus 2 times by 7B is 14B. Okay, and remember that was for F to G, so arrow goes this way, F to G. So we write that 8A plus 14B. So now we have all the things that we need. We can now find F to E. So to go from F to E, we need to go via FG. So FE is equal to FG plus G to E. All right, so let's write that down now. So F to G is equal to 8A plus 14B. And then we are going from G to E, going against the arrow. So that's minus 2A and minus 15B. Collecting like terms, 8a minus 2a is 6a, and 14b minus 15b is just minus 1b or minus b. So our answer is 6a minus b. 4 marks. So remember, going in the direction of the arrow where the arrow is pointing, you keep your values. If you have to reverse them, then you have to change the signs as well. And finally, guys, we are on to the last question of our walkthrough. A long journey indeed. So, is BCD a straight line? So we're checking, is BCD a straight line? We're asked to show working to support our answer. So the key point here, if BCD is a straight line, then either BC is going to be a factor of BD, or we could say BD has to be a multiple of BC or CD. So that's what we're after, checking to see if either of BC or CD is a multiple of, is a factor, sorry, of BCD. So in order to do that, first thing we need to do, we're going to have to work out what is BC and what is CD. So let's go for working out BC first. So BC is equal to, let's plan our route. We need to go from B to A. So B to A, and then we need to move from there from A to C. So A to C. So B to A, we're going in the direction of the arrow, so that's 5A minus 2B, plus for this one, we are going against the arrow, so we have to now do minus 3A and then minus B. So collect like terms now, 5A minus 3A is 2A, and minus B minus 2B is going to be minus 3B. So we tick that off. We have found BC. Let's put that on the diagram. So that is 2A minus 3B. So now we need to work out what is CD. So C to D. So to get from C to D, we need to go CA, and then we are going to go from A to D. Okay, pay attention to your arrows now. So C to A in the direction of the arrow, that's 3A plus B, plus we're going same direction of the arrow here, so that's 3A and then minus 9B. Simplify. So 3A plus 3A is 6A, and minus 9B and positive B is minus 8B. Beautiful. So now I've got CD here, so I've got 6A minus 8B. So now let's check. If we can find a scale factor that links these two together, then we can conclude that it's a straight line. So let's see. What if how do I get from 2A to 6A? I need to times by 3, but let's see if it's the same when I multiply this. So 3 bracket 2A minus 3B. It should produce, so 3 times that is 6A, 3 times this is minus 9B. So we can see in this one, it's minus 8B. It doesn't produce exactly that. If it was on the same line, then when we times this by 3, we would get 6A for this, and it would have been 9B for that. Okay, but that's not the case. So therefore, we can say then, not a straight line, so not a straight line, not a straight line. So then we're going to write BD is not a multiple of BC or CD. Okay, so if it was, then clearly we would have seen that when we multiply that, the same scale factor that links the A term here would be the same scale factor that links the B term. So these two were linked by multiplying 3 times 2A here, gave us the 6A here. However, when we multiplied 3 by minus 3B, instead of getting minus 8, we got minus 9B. So therefore, it's not a straight line. BD is not a multiple of, so BD, which is this one, is not a multiple of BC here, or it's not a multiple of CD. So therefore, not a straight line. And guys, I cannot stress it enough how tired I am right now. And you know, at the beginning, I told you how sick I have been. And so, guys, I really put out all the effort I had just to help you guys. All right, made a little bit of blunders here and there, but that's just due to the fact that I've been shooting the entire day. So now I'm extremely exhausted. And so, guys, I wish you all the very best in your revision, and I've come at a different angle this time just to make sure that you get everything you need for paper 2 and 3, and we don't know which paper will have what, but the prediction is that among the 2 papers, there is going to be these topics somewhere. And so then, once you revise this thoroughly, you would have been prepared for any question, any topic. Where the question is that you can't do doesn't exist at all. Guys, remember we are on TikTok. We still have the shorts questions over there as well that you can watch, and also the shorts on YouTube as well. And make sure that you share this with a friend. Practice as many times. You got a few days that you have that you can go through this video. And guys, I appreciate you so much being a part of my community, and all the best for your paper 2 and your paper 3. And until my next upload, guys, thank you so much for watching.